Entonces es mayúscula, primera mayúscula. C36, D de dedo, 400.
¿Pero la D es mayúscula?
Sí, y todo mayúscula ahorita. 498, AF 95, sí, 95, igual mayúscula, NPY, P, minúscula W, mayúscula Z. Y ya con eso. Están muy chingones los vecinos.
Ah, espérate.
No te preocupes.
No, ya puedo. Espérate que voy a abrir un poquito el plano.
Gracias a nosotros, encantados y felices de estar aquí. Muchas gracias.
A ver, si lo muevo y se desconecta, ¿qué pasa? ¿Se muere?
No, porque tengo 6. Está multiplexando 6 sin celulares.
Ah, ok.
Okay. O sea, ahora, a las 11 sí va a ser un problema porque va a estar todo el mundo discutiendo y ahí metiendo el equipo. Pero antes de eso no hay problema. Y ahora no me pasa nada.
Lo voy a mover un poquito.
Porque yo lo pongo ahí.
Hey, Robert. Robert, you calling me?
I'm Jeffrey Kluger, editor-at-large for Time. Thanks for watching as we trace the path of today's total eclipse of the sun across 15 U.S. states and hundreds of cities from southwest Texas to northeastern Maine. We're making such a big deal about this eclipse because eclipses are a big deal, in part because they're so infrequent. Total eclipses occur when the moon passes directly between the Earth and the sun, blocking solar light. Since 1900, only 12 have touched the U.S. mainland, most of them only glancingly. On average, a total solar eclipse will happen where you live only once every 375 years. Why are they so rare? Well, the sun is about 400 times larger than the moon, but the sun is also 400 times farther away, so the two bodies appear about the same size to us on Earth. The moon orbits the Earth once each month, So why doesn't its shadow touch the Earth, causing an eclipse with each pass? Partly because the moon's orbit is tilted slightly, which causes its shadow to miss the Earth most of the time. But it's also because the moon's orbit is elliptical. For much of its path, the moon is farther away from Earth and appears too small to block out the sun completely. Those eclipses are called annular. Only when the eclipse occurs at the moon's closest approach is a total eclipse possible. Even then, the narrow band of totality usually tracks over water or away from population centers. That's why this eclipse on April 8th is so special. As it crosses the Texas border at about 1:27 p.m. local time, cities closest to the center of the path, like Waco, Cleveland, and Buffalo, could witness up to 4 minutes or more of darkness. In all, 31 million U.S. residents live in the path of the eclipse. Even if you don't live in the path of totality, most of the U.S. will experience some level of darkness. It's a 2-hour spectacle that you don't want to miss, because the next total solar eclipse to hit the U.S. mainland won't be until 2044. Perhaps the most important thing to remember about watching an eclipse is that you need to protect your eyes properly. I have these glasses, and I did a fair bit of research before buying them. We asked Rick Feinberg at the American Astronomical Society to explain what you should make sure you have ready to go.
We recommend that people equip themselves with Eclipse Viewers. They come as in the form of cardboard framed eyeglasses or plastic framed eyeglasses, also little cardboard handheld viewers, sometimes thick cardboard. And they have special filters in them that are supposed to meet a certain international standard called ISO 12312-2. You'll often see that number printed on these products. That's if a product meets that standard, then it is perfectly safe to use to look directly at the sun. The ISO 12312-2 standard is both a standard of what makes a solar viewer safe, but also what makes a solar viewer usable. It specifies the maximum amount of light that can get through, not just in visible light, but also in ultraviolet and also in the infrared. Solar eclipse glasses, a solar viewer, is at least 1,000 times darker than even the darkest ordinary sunglasses. So if you can see anything through it other than the sun, you should be concerned. So what I tell people is look around in the house. If you can see things, you see detail in the house, your glasses aren't dark enough. If they pass the indoor test, take them outside. Don't look at the sun, just look at the landscape. Again, if you can see the landscape through the glasses, they're not dark enough. Now, if you pass that test, you've looked inside the house, you've looked outside the house, and you don't basically see anything, take a brief glance at the sun on a sunny day. Don't wait for April 8th. If the sun looks round and sharp-edged and comfortably bright, your glasses are almost certainly safe. The reason I say almost certainly is because genuinely safe eclipse glasses will also block most of the sun's ultraviolet and infrared radiation. We only see the visible light, but there is ultraviolet light, which you know can damage your corneas. It's one of the reasons we end up with cataracts, too much exposure to solar ultraviolet. And infrared radiation is heat radiation. So the last thing you want to do is cook your retina. The last thing I want anybody to do if they haven't been able to get their hands on eclipse glasses or other solar viewers is to decide that there's no safe way to view the eclipse, so they have to skip it. There are other safe ways to view a solar eclipse. The most common one is what we call pinhole projection. It's a bit of a misnomer because you can use holes that are bigger than the ones made by a pin. A very simple pinhole projector is just to take your hands and create a little waffle pattern with your finger. And then projection is done with the sun at your back. So you put the sun at your back and you look at the shadow of your hands with the crossed fingers on the ground, and you'll see little crescent suns in between the shadows of your fingers. So you've created pinholes with your fingers. Another great pinhole projector is a colander from your kitchen. or a perforated spoon that you would use to strain soup. Anything with a bunch of small holes in it makes a great pinhole projector. The only time pinhole projection doesn't work is if you happen to be in the path of totality during the few minutes when the sun is completely blocked by the moon. The sun in total eclipse is faint enough that it's not going to create pinhole images through any of these projectors that I was describing. But during the partial phases, or even when there's no eclipse at all, you can use pinhole projection to see an image of the sun. So it's important to know that during the total phase of a total solar eclipse, when the moon is completely blocking the sun's bright face, and this only happens if you're in the path of totality, it is perfectly safe to look at the sun without any eye protection, because the totally eclipsed sun, when the sun's outer atmosphere, the corona, shines forth, is only about as bright as a full moon. So it's just as safe to look at. But at any other time, during the partial phases that precede and follow totality, and the entirety of a partial solar eclipse, which is all you'll get if you're outside the path, you must use some kind of safe eye protection, because the sun, even if it's only a thin sliver, is so very bright that looking at it for more than a second or so is going to cause damage to your retina.
If you missed today's eclipse, you will need to wait another 20 years, which is why a lot of people are seizing the day. An estimated 31 million Americans will be able to see today's eclipse, if the clouds are willing, of course. It may not have the same economic impact as, say, a Taylor Swift concert, but the sun can bring in big bucks too. Up to 4 million people are expected to have traveled to the towns within the band of totality. Those are the places where the moon will completely cover the sun. So if we add up airline tickets, hotel accommodations, meals, and other travel-related expenses, the event is expected to inject up to $1 billion into the U.S. economy, according to Forbes. We spoke with some eclipse hunters as they were planning their trips.
When I was in high school, I was part of the astronomy club in Columbus, Ohio, where I went to school. And they had a lecture one day on a group that went from Ohio to Africa to see an eclipse in, I believe it was 2003. And at the end of the lecture, they said that if you want to see one of these and not travel that far, your first chance is going to be in 2017, as there's one crossing through the US. So waited 14 years or so to see the one in 2017, and I would absolutely wait every second of that wait again if I had to.
Total eclipse of the sun.
Every eclipse is different, every eclipse experience is different, especially if you have to travel to so different countries. My goal was not to go only to the US for the eclipse. Actually, the challenge is to be on vacation for 2 weeks and see northern lights and the total eclipse and storm chasing in Texas, maybe see a tornado. Those three things in 2 weeks vacation would be that's the challenge, actually.
I do check the weather. I obsessively check the weather. So the prospects in upstate New York, I'm hoping to see it around Rochester, that kind of area, is not as good as it could be. But hey, if you're not there, the chances are zero. I mean, obviously there are factors around trying to choose places with good weather and all the rest of it. But, you know, practicality terms, if you've got a family, there's a difference between taking a flight to Toronto that costs $400 or one that's going to be $3,000 to Texas and much longer time distance. And it's just, so for me, that's what it was about. But I would choose somewhere that has what works for me, a balance of weather prospects, practicality and affordability, and things to do, because I've got 2 kids and I work, and it's just not possible to pay for that.
We started planning this trip probably about maybe 2.5 years ago or so. And at the time, we were initially looking in southern Texas. At the time, though, even 2 years ago, everything in the area was sold out. So that was number one to make us consider looking at other places as well. So we're going to be watching it from a city in Mexico called Torreon. And it actually is, based on our knowledge of the historical cloud patterns, the lowest chance of cloud cover for the entire center line of the eclipse path.
A lesson here is, if you are really committed to see this one, it should be good to be a bit mobile, you know. You may need to go to some other place. I have a direct flight from Istanbul to Houston, which is taking like 13 hours, but I'm used to it, you know. Yeah. once or twice a year maybe. Like, it's not bad. Okay, this is my vacation. I'm normally a civil engineer, so yeah, I have my paycheck, but I always save a few dollars, euros, whatever, for the eclipses.
And there are some people that just look at it and they go, okay, that was cool. For me, I'm not in any way religious at all, but it's almost as close to a religious moment as I think you can get without being religious. The world carries on, but it's like something changes in you, and I've seen it now. You'll never forget it.
Preparing for this kind of influx of visitors doesn't just earn money for a lot of small towns, but costs money too. Ohio is spending $1 million to boost first responder and emergency management capability. In New York State, the Chautauqua County Legislature is allocating $200,000 to boost the availability of EMS equipment, as well as portable cell towers, highway message boards, and traffic flares. And Erie County is buying $100,000 worth of Eclipse glasses to help protect visitors' eyes. The county is expecting a lot of outsiders, but also locals will be watching. Students have been given a day off from school to celebrate the sun. We spoke with Jennifer Dunmeyer, supervisor of math and science for Mill Creek Township School District in Pennsylvania.
The motivation behind canceling classes for that day really started with our student safety. If we look at our area and when the eclipse is going to happen at that time, it's right at our elementary dismissal. And the projections of the number of folks who will be joining our area for that day, we really want, our students and staff to be able to get to their homes, to get to be safe and enjoy this once-in-a-lifetime opportunity. We've been afforded an opportunity by a partnership with our local Penn State branch, Penn State Barron, because of their planetarium that they have on their local campus. I knew that they were going to be doing a lot of, community outreach. They've been able to give us Eclipse glasses for all of our students and all of our staff. We went ahead and we sent home a sheet on how to use them safely and how to view the eclipse safely. Teachers are modeling that and demonstrating that with their students. These folks have taken time and energy to go ahead and put together resources from lesson plans, activities, a playlist, which I think is great, to be able to listen to while you're enjoying the eclipse and prepare. So understanding the phases of the moon, for example, understanding the pinhole projectors. We had a local professor from a university come into one of our elementary schools and meet with the grade levels to show them the phases of the moon and give them the opportunity to ask one of the experts, on the eclipse, just different questions. And their questions, oh my word, they ranged from everything from the distance that the moon is from Earth to the distance to the sun to, what we're seeing right now about the solar flares and the geostorms and all of those things that are happening. We're sparking this new generation of learners who are going to go outside and look up at the stars and be enamored, and ready to, go forward and make changes. And who knows what they'll go and experience.
I imagine seeing an eclipse is something those kids will remember for the rest of their lives. They certainly have a place in the world's shared history. The Lydians and the Medes ended their war in 585 BC when a total eclipse darkened the sky and convinced the combatants that it was a sign of disapproval over the ongoing fighting. The English saw an unhappy cause and effect between the eclipse of August 2nd, 1133, and the death of King Henry I, even though Henry died more than 2 years later. In the Odyssey, Homer recounted the eclipse of 1177 BC, writing, "And the sun has perished out of heaven, and an evil mist hovers over all." Over time, of course, humans became less superstitious and more scientific, and an eclipse became not an occasion for fear, but an opportunity to learn. During the total eclipse of August 18, 1868, French astronomer Jules Janssen studied the prominences, the flames and flares that dance around the edges of the sun's blacked-out disk. Looking through a spectroscopic prism, he saw the signature of helium, thus discovering the second lightest element in the universe, even before it had been found on Earth. Much more significantly, on May 29, 1919, British astronomer Arthur Eddington used a total eclipse to prove one of the premises of Einstein's general theory of relativity, that gravity will bend light by a predictable amount. Months before the event, Eddington measured the precise position of the Hyades star cluster. Then, on May 29th, when the sun was blacked out and the stars popped into view, he measured it again, and it was different by a factor perfectly consistent with the bending Einstein had predicted in his 1915 theory. The Times of London announced the discovery with the headline, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." That, in some ways, illustrates one more gift of the solar eclipse, that it allows for two different kinds of vision, the aesthetic and the insightful, the glimpse of beauty and the glimpse of the working of the cosmos itself. The last time the continental U.S. was cast under the glow of a total eclipse was in 2017. It was slightly different from today's in the sense that it traveled from the northwestern U.S. to southeast rather than southwest to northeast. But the mystery of an event like this doesn't change. In 2017, I sat down with Anne Druyan, who is the widow of Carl Sagan and the co-creator of the TV series Cosmos. She spoke to me then about how an eclipse is an opportunity for reflection and reevaluation.
That sudden chill, the motion of the birds, the way that the rest of life reacts to the blocking out of the sun is almost, it has that kind of mythic, biblical power to it, and it should have it. For how many countless generations, we applied the kind of false pattern recognition. So, there's a darkness at noon. Oh my God, that means that the king is not in favor, or gods are angry, or we have committed some terrible sin by sleeping with the wrong person or eating the wrong food on the wrong day, things like that. But it's also the beginning of figuring out the universe. What I love so much about science is, for me, it is informed worship. It's a high degree of humility to say, we know nothing, we're very young, we're very new at this. Give us a machine that can ferret out those misconceptions and enable us to see nature as she really is and to love her as she is. That to me is defining in love. I mean, really, when you love someone, is it good if you just love the illusions you have about them? Or is it really a deeper love to want to know them as they truly are, to love them so much that you will not turn away and flinch at reality? That soaring spiritual joy, that goosebump raising feeling of being part of nature and understanding it even a little is one of the greatest human experiences.
When an eclipse passes overhead, it changes the atmosphere, technically the ionosphere, which is the band of atmosphere that ranges from an altitude of about 60 to 300 kilometers, or 37 to 190 miles. That may cause such problems as disrupting the transmission of radio signals, although the interference is usually too brief and subtle for people to notice. You might notice also that it gets cooler where you are. Falling temperatures near the Earth's surface also may cause what's known as an eclipse wind, or a slowing of the wind. That's the result of low-level air becoming cooler than the higher-level air, what's known as a temperature inversion, which makes it harder for that more elevated atmosphere to mix with the air closer to the ground, eliminating the temperature and density differences that lead to breezes and gusts. As totality ends, the winds pick back up. Another effect falling temperatures may have will be the appearance of a fleeting thunderstorm, as cooler air closer to the ground pushes warmer, more humid air upward, where moisture then condenses and rains out. The process is similar to the way ocean breezes can cause brief storms in the summer. You, of course, are expecting this and know why it's happening. Non-human animals are less prepared, and today's eclipse is a boon to scientists who study such things.
While most people will be looking up at the sun during the April 8th total eclipse, researchers at the Fort Worth Zoo in Texas will be looking at the animals.
Animal behavior is only actually a small part of the research we do. Mostly we study skulls and we do dissections of animals.
Adam Hartstone Rose is following up on studies done at a South Carolina zoo that was in the path of total darkness in 2017.
There was just this amazing opportunity where we were in 2017 to see these animals, interesting animals, and in this interesting phenomenon that was about to happen. And so we put together a study during that, and I think I basically became hooked.
There is lots of anecdotal evidence of animals behaving bizarrely during eclipses, but more rigorous scientific study is newer.
One of the animals we watched was the Komodo dragon, which are magnificent. They're the biggest lizard. They're amazing. They're a little bit scary, but they don't do anything. Like in general, a Komodo dragon sits still for almost all hours of the day and absorbs the sun and maybe is digesting. The Komodo dragon we were watching before the 2017 eclipse, it literally didn't move at all. We watched it all day Saturday. We watched it all day Sunday. Then the eclipse was on Monday. And just in those couple minutes during the eclipse, it started running around and had a reaction. Some of the animals behaved as if evening had come, so they went into their nighttime routine. The gorillas, and they spend their day outside, and then at night they're moved into like an indoor enclosure where they get their final food and then they go to sleep. And in the middle of the day, the whole group of gorillas wandered over towards the enclosure as if to be let in at night.
There's also a call for citizen scientists to observe animals, even your own pets.
This time around, we're going to look at some of the same types of animals. So we're going to look at a different group of gorillas and see if they behave the same way as previously. We're going to look at another group of giraffe. It sounds like a lot of what we know about animal behavior during eclipses is hard to believe. And yes, most of it is based on one person's observations of potentially one animal. But the only way that we can confirm this stuff is to take every opportunity that we can to go out and witness it ourselves.
One of the most striking examples of animal behavior that I've read about involved a captive troop of chimpanzees at the Yerkes Primate Research Center on the campus of Emory University in Georgia during an annular eclipse on May 30th, 1984. As researchers reported in the American Journal of Primatology, the animals moved to the highest point of a climbing structure in their enclosure and turned their faces upward in the direction of the sun and the moon. One juvenile gestured toward the slowly vanishing sun. The chimps remained that way until the skies began to brighten when they descended from the structure. No one can ever say with certainty how they were experiencing what they were seeing, whether they felt their own form of curiosity or wonder or even reverence. Clearly, though, they were captivated by it all. I can certainly relate. I've seen 2 total eclipses in my life, and it never gets old. Keep watching here to see a live stream of the eclipse as the sun works its way northeast. And if you are going outside to watch it yourself, please remember to take care of your eyes. Make sure you are using a proper pair of solar filters. Enjoy the sky show.
No veas pues.
Hola, ¿cómo estás? Estaba abierto. Eso, pero ahorita allá arriba para acá. Ya se subo hasta acá.
Creo que va a venir tu mamá, está preguntando dónde estamos. Mira, Catalina, mira, ven. Parece el ron.
No sé dónde salieron tantos.
Muy bueno, por favor. Mira, ¿tiene que ver el ron?
Sí. Oh.
En un momento más incorpora.
No, no te lo quité.
I'm Justine Simons with Time, and I'm joined here in our offices in New York by Professor David Helfand, who is a professor of astronomy at Columbia University and also chair of the American Institute of Physics. David, welcome.
Thank you. Pleasure to be here.
It's great to have you here. We'll answer viewer questions. We'll talk about eclipses past, present, and future. There's a lot to discuss, right? We're looking right now at the live scene in Mazatlan, Mexico, as lots and lots of people are gathering to watch eclipses. David, how many eclipses have you seen?
I've attempted to see 3 and seen all 3 of them, which is why I'm not traveling today. Figure 3 for 3 is a good record.
Third time's a charm and all of that. Tell me some of your favorite eclipse memories.
Well, the first one was in February of 1998. I had gone to my 25th college reunion, and one of my classmates came up to me and said, "David, I have to talk to you. I founded this company 10 years ago, and we're going to celebrate its 10th anniversary. The company's really a phenomenon, so I wanted a phenomenon to go with it. And I discovered there's an eclipse in the Caribbean on the week we founded the company." And so I said, "Well, clearly you need an astronomer." He said, "That's why I'm telling you, I need an astronomer to come with us on this. I've got this boat that's 500 feet long and it holds 200 people, and we're going to go." So we did, and we positioned the ship off Montserrat, where the Soufrière volcano was erupting. So there was a 60,000-foot plume of volcanic ash in one direction, and the solar eclipse shadow sweeping across the Caribbean in the other.
Okay, I feel you're just showing off now.
It was a memorable first eclipse, I would say.
Wow, that's amazing. And that was a total eclipse, right?
It was a total eclipse, lasted about 4 minutes, so we had everyone with binoculars with solar filters to watch the ingress and egress, but during the moment of eclipse, We take the filters off so you can see the corona of the sun and the other planets in the sky. And one of the company's lawyers was on the boat and was very nervous that people had their filters off. And I said, we know how long it's going to take. It's not going to be a problem.
Well, but that's a really good question. We should talk a little bit about eye safety, right? Because it's a serious thing.
Oh, it's a very serious thing. The sun is very bright, and it's not just the light you can see. Our eyes are sensitive only to a single octave of light, the light spectrum. But there's ultraviolet light and there's infrared light, both of which can damage your eyes. The ultraviolet light damages your lenses and your cornea, and the infrared light will just cook your retina, both of which are bad and can happen in seconds.
So normally when we go outside, we are wearing sunglasses or nothing at all, but the difference is we're not staring at the sun because you just can't, right?
I hope not.
Yeah.
I hope not. And sunglasses, while they may seem dark to you, make it comfortable to be outside in a sunny day, are 1/1000th the level of density you need to block the sun's ultraviolet, infrared, and visible radiation.
Okay, that's good to know. And so let's talk about eclipse glasses. All right, these are my eclipse shades. They're even called eclipse shades. I mean, there's some special technology that goes into these, even though they look like pieces of cardboard with tinfoil on them.
They are pieces of cardboard, but the lenses have been coated such that they screen out both the ultraviolet and the infrared rays as well as the visible light. If you can see anything looking through those glasses in your house or outside in the yard, that means they're not good enough to look at the sun. The only thing you should be able to see is the sun.
Right. Okay. So that's good to know. And also there is, you want to make sure that you have actual legal official stock eclipse glasses, and they should have this information on them, right? ISO, is this the number that I'm looking at, David?
Yes,
ISO
that's right.
12312-2.
It's just 12312.
12312. Okay.
And if you want a set of recommended places, although it's a little late to buy them now, eclipse.aas.org has all of the official manufacturers listed.
Okay, that's good to know. It is a little late now, but there are alternatives, right? I mean, you don't, if you're not going to look at the sun, or even if you decide that it's not safe to look at the sun, which I know some, I'll just say, just don't ever risk it. You can make a sort of pinhole viewer, a pinhole projector.
Right, so there's many ways to do this. What you want to do is make a small aperture through which the light passes. So you can take your fingers and overlap them perpendicular to each other in a tic-tac-toe pattern, and you'll see 4 little images of the sun and the moon encroaching on it. You can take a colander, which could give you dozens of little images of the sun. If you're in a place where the leaves have come out yet, they haven't come out yet in New York, you can sit under a tree and then you'll see hundreds of little images of the sun being eclipsed by the moon. So anything with small holes in it, you can just take a piece of white paper, punch a hole in it, and with a pen, and project it onto the ground, and you can see the eclipse in progress.
Great, and you put the sun behind you, or the eclipsing sun, yeah? Okay, great. All right, you've told us the story of your first total eclipse, which was, I can't decide if I'm more impressed by the volcano or the eclipse because they were simultaneously happening. Your second eclipse?
Second one was just the next year. So I was on a research leave at the University of Cambridge, and there was going to be an eclipse in France, in Normandy, just across the channel. So of course we went, rented this 15th century farmhouse. And the day of the eclipse it was not looking promising because it was pretty cloudy. There were a few little breaks. So we got in a car and frantically chased holes in the clouds until just 15 minutes before the eclipse, we found this field full of cows where there was a bright blue patch of sky. We witnessed the whole eclipse, and the dramatic part there was the cows, as soon as the eclipse became total, the cows all started moving and went back to the barn to get milked because it was nighttime and that's when you get milked.
So that's a thing.
Oh, it's a real thing, yeah.
The animals will get confused, right?
Well,
or,
they don't know what's happening, obviously.
Yeah,
it's getting
right.
dark, it's time to go get milked. And
yes.
Birds stop singing at dusk, they stop singing.
Yeah. We ran a story earlier in the show about, scientists who are studying animal behavior. I mean, obviously this is not such a regular opportunity, so there is probably a lot of work happening right about now.
Yeah, I read somewhere that some zoo has a whole bunch of volunteers monitoring all the different animals to see how they respond.
Yeah. And actually, there's a project to monitor your house pets as well.
Mm-hmm.
Do you think they'll behave differently?
Possibly. I don't know. If they're outside. If they're
Yeah.
inside, they probably won't notice. But it's possible that dogs and cats would react.
You would think. My colleague went to get Eclipse glasses at the New York City Public Library because the library was giving out, has I think now given out all of them, thousands and thousands of pairs of Eclipse glasses. And the woman in front of him was picking up a pair for her dog.
Yeah, well, I think dogs are smart enough not to look at the sun. So I don't think that's really necessary.
It was the most New York City thing ever. You gotta love it, though. Okay, your third eclipse? I love
Third
that you
eclipse
have three
was the
stories.
last great American eclipse, which was in August of 2017. And we had cleverly arranged the High Energy Astrophysics Division of the American Astronomical Society to hold a meeting simultaneously with the eclipse so we could gather several hundred astronomers together to share in the experience of the eclipse. And we had rented a space, a hotel in Jackson Hole, Wyoming. Being very clever 5 years in advance, they of course didn't know there was an eclipse, and so they didn't charge us extra money. But then, unfortunately, the hotel got sold and turned into condos, so we had a last-minute frantic search and ended up at Sun Valley in Idaho, which was equally nice, so it was fun.
Oh, you had to downgrade to Sun Valley in
That's right.
Idaho. So I have heard people say it's total eclipse or bust. Is that true? I mean, I'm asking, really, here we are in New York City where it's a partial eclipse, and I think people still seem excited. I am.
Well, if you have the right glasses to watch it, a partial eclipse is really interesting because this purely black shape moves over the surface of the sun, but the sun never gets fully eclipsed. And the difference, yes, it's 99% and 100% are completely different. The 99%, the sun is still 1,000 times brighter than the full moon, and you cannot look at it without the glasses on. At 100%, the sun is not bright at all. It's less bright than the full moon. All you see is the outer atmosphere of the sun called the corona, and that's beautiful and spectacular and can only be viewed during an eclipse. But the 99% eclipse is just not the same experience.
So it's a bucket list thing for sure.
Yes, and there are places on Earth every year where there's an eclipse.
Right.
It's just that a lot of them in somewhat remote places.
Right.
and
We're
not
we're
cheap
spending
to get
so
to.
much time and giving so much attention to this particular one because it crosses, our whole.
Crosses the country, yes.
Yep.
And if you're lucky enough to be in Carbondale, Illinois, then you got to see the one in 2017 and the one in 2024 as a total eclipse.
Double lucky. Yeah. Okay. That's good to know. All right. So, shall we talk a little bit about the history of eclipses, aside from your own personal history of having seen so many? Here in New York, when is the last time this city saw a total eclipse? Which I should say we are not going to see today on April 8th.
No, we're not. Only 90% today. 1925 was the last total eclipse in New York. And in 1925, we didn't know the orbits of the moon and the Earth and the sun sufficiently accurately to know exactly where the edge of totality was going to be. And this was considered worthwhile finding out. And so Con Ed stationed observers on the rooftops of every building up Riverside Drive. And what they determined was that the edge of the total eclipse pattern was 96th Street. So if you were above 96th Street, then you got to see a total eclipse. And if you were below 96th Street, it was only a partial eclipse.
And there must be some fun mementos and photographs and things from that.
There are photographs of people standing on the roofs. It was in January, and it was 0 degrees Fahrenheit, so it wasn't a pleasant experience. But they did get to see the total eclipse if they were above 96th Street.
Do the seasons make a difference, or is it just truly a weather pattern is a weather pattern?
No, the seasons aren't connected in any way. The seasons are a consequence of the Earth's orbit around the sun, and of course the moon follows the Earth around the sun.
Sure, but will they make a difference in what you see?
No, not really. In the winter time, if it's very clear, there's somewhat less water vapor in the atmosphere, so it might be slightly sharper, but you probably wouldn't notice it.
And what about sort of opportunities for scientists historically? Maybe, shall we speak about that?
Well, by far the most important scientific discovery made during an eclipse was in 1919. Albert Einstein had 3 years earlier published his radical new theory of gravity to transplant Newton's theory of gravity, and it made a specific prediction that the light of any star passing close to the sun should be deflected by twice the amount that Newton's theory would have suggested. Now, a factor of 2 is a big effect, but it's very hard to measure light from stars near the sun because, of course, when the sun's up, you can't see the stars. So what Arthur Eddington and Frank Dyson did was launch expeditions to Brazil and to Principe, the island off Africa in the South Atlantic, and they set up to measure the eclipse 6 months in advance, so that then, of course, it was dark because it was 6 months earlier. And then during the eclipse itself, they again measured exactly the same stars and showed the shift in the position of the stars that was completely consistent with Einstein's new theory of gravity.
Okay, interesting. I mean, that's a big breakthrough, right?
That's a major transformation of our understanding of one of the fundamental forces of nature, yes.
Yeah. What are the experiments that are happening sort of today? Is there anything that you're keeping an eye on? I mean, I told you they're studying animals.
Yes, they are studying animals. They're studying the Earth's atmosphere because, of course, the Earth's atmosphere responds to a sudden change in the insolation, the amount of energy coming from the sun. And so I know there's a student project along the path of the eclipse. They're launching weather balloons to measure the temperature profile and density profile of the atmosphere along the path of the eclipse. Scientists are also studying the corona. That's the very hot region around the sun's surface that we normally can't see because it's so faint compared to the sun, but is brilliantly visible. The sun has an 11-year activity cycle, and we're approaching the peak of that cycle when there are most solar storms. And so the corona should look a lot more active than it did in 2017 when we were near the minimum in the cycle. But the point is that now we have techniques to make artificial eclipses with an instrument called a coronagraph that blocks out the sun. It's not perfect, it's not quite as good as the moon, but we can study the sun all the time, and then we also have satellites orbiting the sun that can measure the corona. So there will be some experiments on the corona, but they're not going to be of the revolutionary nature that Einstein's theory of gravity was.
Yeah, yeah. Okay, let's first put a shout out to our audience that we will be answering questions. So if people want to pop their questions into the chat, if you're watching on YouTube or Facebook, David is kind enough to answer them now. So let's look here at some of the questions. All right, well, here's a really basic question, which how long will a solar eclipse last?
Well, that depends where you are, of course. If you're right on the center line of totality, in this case, it'll be 4 minutes and 30 seconds if you're on the Texas-Mexico border, and it'll be just under 4 minutes if you're in Vermont or Maine.
Okay.
That ranges from just seconds if the moon is in an unlucky place in its orbit, to as much as 7.5 minutes is the longest total eclipse that can happen.
Oh, 7.5 minutes. Oh, that is a long time. Wow. Okay. In this time around, I think the longest place is 4.5. Yeah, 4.5. Yeah. Okay. All right. Someone asked, can you look, and I guess this is if you don't have proper eclipse glasses, again, PSA, do not look at the eclipse without proper eclipse glasses. Can you look at the reflection on another surface, like a mirror or a car window, and still be safe?
You will be safe, but I suspect you won't see very much because the mirror will reflect the bright point of light that is the sun, and you won't see it distributed with the moon covering it up. So yes, you can certainly safely do that, but I don't think it'll be very rewarding.
Mm-hmm. But one potentially rewarding alternative to not looking again with your eclipse glasses, but not looking at the eclipse, is to make a pinhole projector, right?
Exactly.
Yeah. Okay. Here's a cute question. Pets, any tips?
As I said before, I think pets are smart enough not to look at the sun, so you don't have to worry about that. And it would be interesting. I don't know. I've never seen my dog during an eclipse, so I don't know if it reacts. I would suspect not, because it's sort of no different than the sun being out and then a heavy cloud coming and covering it up. But it would be interesting. satisfaction of human curiosity to examine your pet's response.
Yes, I mean we do know people are monitoring this in zoos and in homes around the country right now. And you told me the story about cows going inside when the eclipse happened, right?
Oh, absolutely. That if the animals are outside and they respond to light cues. See, dogs and cats I don't think respond that much to light cues, but cows do and birds do certainly. Then you'd expect to see a reaction, and indeed, I did see the reaction.
Right, birds will stop chirping, right? Interesting. All right, here's another sad question that might be all too real for a lot of people in the path of the eclipse today. What happens when it's cloudy?
You don't get to see the eclipse. It depends how cloudy it is. If it's light, wispy cirrus clouds, then you can see it right through it because you can see the sun through those clouds. If it's heavy and dark clouds, you might notice a slight diminution of the light when the full eclipse is in progress, but basically you are out of luck until 2045, 2045.
2045, right. All right, and someone asked a question about the comet that might be seen during the total eclipse.
Yeah, so there is a comet. It's 12P Pons Brooks,
right? Yep.
Yeah. That's up in the sky right now. And seeing it with the naked eye, I think, would be a little difficult, but certainly with minimal binoculars, you could see it if you knew where to look for it. Comets are giant, dirty snowballs, maybe 50 miles across, that spend most of their time very, very far from the sun, 1,000 times as far as the Earth is from the sun. And out there it's really cold, and so they stay frozen. But occasionally they get bumped and nudged and attracted by the planets, and they fall into the inner solar system. And as they approach the sun, they heat up, and the ices and gases on them shoot off into space, giving them their beautiful tails. And sometimes they crash into the sun and are destroyed. Sometimes they orbit the sun and go back out to their refrigerator out in the distant solar system.
Interesting. During the total eclipse, you can see planets
and stars.
And stars, right?
You can see the very brightest stars. You won't see very many of those. But the planets are easily visible because they form a perfectly straight line, because, of course, they all orbit the sun in roughly the same plane. And so they're in a straight line on the sky. And what's interesting about this eclipse is that all 7 of the planets, besides Earth, of course, are in the daylight part of the sky. And so the ones you can see with the naked eye, Saturn, Jupiter, Venus, and Mars, should all be easily visible. Mercury is very close to the sun, so it's a little hard to see. And then Uranus and Neptune are too faint to see with the naked eye, but they're all there. So if you had a telescope or binoculars, you could see all of them. And that doesn't happen very often.
Yeah, I guess you could. That's significant because of the day.
It just happens that the orbits of all the planets have lined up, so they're all in the daytime sky now.
Okay. All right. Well, we're looking at a live stream from Mazatlan, Mexico, which actually Mexico's going to see the longest totality.
Right, and the first landfall. And you can see it's cloudy there, but the clouds are pretty thin, so they should be able to get a pretty good view.
They get 4 minutes and 28 seconds,
right?
Apparently, right?
Right.
Do you remember the eclipses you saw, how long they lasted?
They were roughly 4 minutes. That's the sort of typical one. As I say, the shortest ones are under a minute, and the longest ones are over 7 minutes.
Mm-hmm. Mm-hmm. Any other tips for folks who are getting ready? I mean, we have a couple hours until totality, right? What would you say people should be doing right about now?
Well, they can, first of all, look outside and see if it's cloudy. And if it is, they can go out, whatever they were going to do with the no eclipse. They should make sure they have unscratched and certified glasses, and if not, that they have some object to use as a pinhole camera. Mm-hmm. So a colander or their fingers or a piece of paper with a hole punched in the middle of it.
Maybe we should read through the totality begins, the duration, and totality ends for different places. People might appreciate that, right?
Yeah, well, we said that the eclipse lasts 4 minutes. The eclipse lasts much longer than that, of course, because it takes a while for the moon to cover up the sun, and then it takes a while for it to uncover it again. So in Mexico here, where we are now, the eclipse begins at 12:51 Eastern time, so it's a few minutes away. Totality doesn't begin until 2 hours, 2 o'clock, 7 minutes past 2 o'clock. The maximum is 2 minutes later. The totality ends 2 minutes after that. That's the 4-minute duration. And then the partial eclipse ends at 3:32 in the afternoon. So it's a 2-hour phenomenon from when the moon first takes its little nibble out of the edge of the sun until it blocks it completely. The pattern moves rather rapidly, something like 1,000 miles an hour. So it'll only take a couple of hours from Mexico to when it exits Maine and the Canadian Maritime provinces. So at Eagle Pass, Texas, the totality begins at 2:27 Eastern Time or 1:27 Central Time. In Mesquite, Texas, it's 2:40 Eastern Time, 1:40 Central Time. Arkansas, Hot Springs is 2:49. Carbondale, Illinois, the lucky people who get to see 2 eclipses in the space of just 7 years, it's 2:59. In Trenton, Ohio, it's 3:09. In Cleveland, it's 3:13. In Niagara Falls, New York, which looked pretty cloudy when the feed came through, it's 3:18. And it'll be all over by 3:30 in the northern reaches of Presque Isle, Maine.
It goes by. It feels like it's going to take forever to get there, but then it will go by quite quickly once it actually starts moving, right? And the weather really could change. And also an eclipse could change the weather, right?
An eclipse can change the very local weather very slightly. I mean, what it does do is cause the temperature to fall because there's no more sunlight heating the atmosphere. And it can fall by as much as 5 to 8 degrees Fahrenheit. So you notice it. You notice it gets cooler. And when air cools, water vapor in it condenses. And so that will produce clouds, even if there weren't clouds there in the first place. But unless it was very saturated with water, in which case there probably already would have been clouds there, then the clouds will be sufficiently thin that you can see the eclipse through it. But it doesn't have any permanent effect on the weather.
Right. All right. So we're looking at a live shot from Mazatlan, Mexico. The data we have shows that 31.6 million people live in the path of totality for this eclipse, compared to 12 million during the last solar eclipse that crossed the U.S., which took a slightly different trajectory, right?
Almost perpendicularly. I came on the west coast in Oregon and came across the middle of the country and exited in, I believe, South Carolina.
And this one goes from Mexico up sort of...
Right, so it goes through Texas, which is very populated, and then Ohio and Pennsylvania and New York.
New York, and then Maine, which is not that populated. No. And a lot of people have traveled. I mean, I feel like we're hearing more about this eclipse. Again, I suppose it's in our sort of American-centric universe, but do you think social media has made people more excited about these things?
Well, I don't know.
Made them feel more attainable?
Well, it certainly provides a lot of useful information, as is mostly true with social media. It provides a lot of unuseful disinformation and misinformation as well. But people were excited about these in the past. As I said, the 1925 eclipse in New York, the total eclipse went over Queens, the borough of Queens, and there were about 1 million people living in Queens then, as there are now. And that was in 1925, so when you made a telephone call, you had to call a switchboard, and a lady would plug one plug into your phone call and one plug into the person you're trying to reach. And for the 15 minutes around totality, there were precisely 0 phone calls in Queens, which suggests that all 1 million people were outside looking at the eclipse. So I think it was a big phenomenon then as well.
That's a great data point. The minute that Queens went silent, right?
Completely silent.
Yeah, that's pretty great. So let's talk a little bit about the sun. So during the eclipse, the sun will be at near solar maximum, correct?
And solar maximum means it's most active, it's generating the most magnetic storms on its surface and the most ejections of high energy particles towards the Earth. that follows an 11-year cycle, and we're within about a year of the peak of the cycle.
And let's talk about what I think you were telling me earlier. That is a science we know less about maybe than we should.
Well, it's a really challenging problem. First of all, we don't know why it's 11 years. We know what
the solar cycle is 11 years.
Yeah, why the solar cycle lasts 11 years. The result of this is that the sun is rotating. The sun rotates once around on its axis in 26 days. And beneath the surface is rotating even faster. And the sun, of course, is very hot, so all the particles are charged. And charged rotating particles generate magnetic fields. So these magnetic fields are generated below the surface of the sun. And when they get strong enough, they erupt through the surface of the sun, accelerating particles to very high energies and populating the corona, that glow you'll see around the sun if you get to see the total solar eclipse. They also drive a solar wind, which is a wind of particles, that's like the wind outside, that spreads out throughout the solar system. And they are, among other things, responsible for the northern lights, the aurora borealis, because when those charged particles hit the Earth's magnetic field, they spiral around the field and crash into the north magnetic pole, and that excites the air molecules to glow red and green and other colors. But the sun can, in a particularly violent moment, eject a very large number of these particles in an event called a coronal mass ejection. So the corona, again, is the outer atmosphere of the sun. Mass ejection is what it sounds like. It ejects mass towards the Earth. And this produces a bright flash of light, which arrives in just 8 1/3 minutes, because that's how long it takes light to get from the sun to the Earth. But the particles take a little longer, hours to maybe 12 hours. But when they get here, they can cause serious damage. They can both interfere with the power grid, and they can damage satellites in orbit around the Earth. So in 1859, there was one of these events called the Carrington event, which was quite noteworthy. At that time, of course, we didn't have satellites and we didn't have telephones, but we had telegraph stations. And the amount of high-energy particles irradiating the Earth was sufficient to induce currents in the cables of the system to actually set a few offices on fire.
Where?
In the U.S.
Oh my
and,
gosh.
and in Europe. And so that kind of event today would be catastrophic, because it would shut down, likely, our entire electric power grid. And we're talking over the world, not just in one place. And it would severely damage, if not destroy, most of the satellites in orbit around the Earth. Lloyd's of London has estimated the cost of such an event would be between $2 and $6 trillion.
Is this a kind of an event a certainty, though?
Well, this event has happened every few hundred years in the past. We have records of this going back from natural records, not from human records, of course, because they didn't have telegraphs in 1100. But we know these events occur occasionally. Sometimes the particles are ejected in a direction that misses the Earth. That happened recently, actually. A very strong event happened, but it ejected things in the direction that wouldn't hit the Earth. So that's fine, doesn't bother us at all then. But the possibility of this happening is real, and we don't know how to predict it, because we don't understand these magnetic storms sufficiently well.
And there's no way to redirect it.
No.
Right. I mean, it's not like we see it's bigger than us. Wow. And who are the people on Earth then who are studying this, trying to solve for it, and what are the protections that would be put into place?
Well, this is called space weather, because it is like weather. It's changing conditions in the space, interplanetary space between the sun and the planets. And there are many people that study space weather now. We have satellites orbiting the sun rather than orbiting the Earth in order to study this. But it's a complex process which we can't fully understand or predict. I mean, some things are just not predictable. Earthquakes, for example, which we had one in New York a couple days ago, they are just not predictable. That's the way it is. And we just have to learn to live with them. What can we do? Well, satellites, of course, are hardened against radiation to the extent they can be. But there's a trade-off. You can encase an entire satellite's electronics in lead, but lead is very heavy. That makes the satellite harder to put into orbit. So there's always a trade-off there. On the power grid, we have a very old and not terribly well-designed power grid that's been built up over 100 years of electrification. And if we had a more modern one, not only would it help protect us from this, but it would also allow us to more readily add renewable sources of energy to the power grid.
Right. Okay. I'm just moving my microphone a little bit because I think. Okay. All right. So that's a scary thing, the Carrington event that we don't want to see again. But does an eclipse offer an opportunity to study this during only moments of totality, or?
Yeah, it's only during moments important of totality that you can see the corona in its full glory. And the corona is where these events take place. But unless an event is happening, and they don't happen that often, it's probably not something that an eclipse is going to provide a lot of deep insight into.
Okay. Well, so it's just another thing to put into the category of beyond our control right now, maybe?
Yes.
Okay, great. Thanks. Okay. Oh, we actually we have some video that we could run, I think, if Amy in our control room says it's ready, which is a NASA clip of the shadow that gets cast over Earth. Do you want to just talk us through what we're looking at here?
All right. So in this case, the sun is off to the right, and so you see the Earth and the moon, and you see the shadow, and just a tiny strip of the shadow reaches Earth, and this is today's eclipse. So you see it's moving over the Pacific Ocean, and it's about to enter Mexico right about now, actually, in real time. And then we'll scoot along at 1,500 miles an hour through Texas, Arkansas, Ohio, Pennsylvania, New York, Vermont, New Hampshire, and Maine, and off through Labrador.
Right. That's pretty great. So that was the path of totality that we just looked at.
Right, and the path of totality is about 100 miles wide. That's not a general rule. That's just for this specific eclipse, because it represents the ratio of the size of the moon compared to the size of the sun, which is constant at 400, to the changing ratio of the distance of the moon from the Earth and the distance of the Earth from the sun.
Interesting. Over water. I mean, did you say that your first eclipse was from a boat?
Yeah.
Yeah. I mean, is that a very different look, or?
Well, what's nice is you can see the shadow racing across the ocean.
Oh, what?
See, because the ocean's flat, obviously, and there's nothing in the way. And when you're on land, you get there's trees and buildings. And
the ocean's flat until in the further distance, it drops.
Well, yeah, so you have to wait for the shadow to come, but the shadow moves pretty quickly. As I say, it's moving 1,500 miles an hour. So.
Wow. Oh, that's amazing. I suppose, would you get the same effect over, like, a field or something?
Well, it's not as big.
Not as big, right.
I mean, 1,500 miles an hour, in a second, it goes half a mile. So you need a very big field to see it.
Wow, that's fantastic. See, nobody talks about that because you have to be, I guess, special to be invited to see an eclipse from a boat, right?
Well, actually, 71% of the Earth is covered with oceans. So most eclipse expeditions that people go on actually are on ships. Because
Oh, good point. Okay, well, maybe I should just add that to my bucket list. All right, let's talk about what happens during the moment of totality. What are you seeing from the corona, and can you describe the streamers coming off of the sun? What are the things people should be looking for? If you are in a place where you will experience totality.
Right.
That's the only place you can take your eclipse glasses off. Nowhere else, correct?
Right, but just before you take the eclipse glasses off, as the moon is just about perfectly matched up with the sun, you'll see what's called Bailey's beads, which are a consequence of the topography of the moon. There are mountains and valleys on the moon, and so where there's a mountain, the sun doesn't shine through it, and where there's a valley, the sun does. And so you get this little speckled pattern around the edge of the moon where the light's coming through the valleys and being blocked by the mountains.
I've heard people yell Bailey's beads, but I didn't realize that's from a mountain on the moon that's causing the irregular shape.
Right.
Wow. Okay, but during that moment, you got to leave your glasses on.
Right, but and when they appear, then you're okay, because that means the moon is really covered up.
I see.
The bulk of the sun.
And then what will
you see? So that's your clue. So you might see the diamond ring effect, which is you just see one of those shines through brightly. But then you'll see the corona. So the corona is thousands of times fainter, but it's always there. And it represents the upper atmosphere of the sun, which curiously is hotter than the surface. Interestingly, the surface of the sun that we see with our eyes is the coolest layer of the sun. If you go deeper into the sun, it gets much hotter. The surface we see is 5,780 degrees. The center of the sun is 14.5 million degrees, so it's much, much hotter. And as you go in, it gets steadily hotter. But also, as you go out, it gets steadily hotter. And so the temperature that we see, again, is 5,800 degrees. But as you go out, the temperature rises to many thousands, then tens of thousands, and then up to 1 million degrees, which means it emits X-rays and ultraviolet light.
Okay, great. Oh, and look, we're looking at a live stream of Niagara Falls, and that is Governor Kathy Hochul, right? Who's just clearly showed up to meet and greet.
But the sky looked pretty grim there.
I know. It's too bad. But there's time, right?
Yeah, they have a while before totality gets to them, so maybe they'll be lucky and it'll clear.
Totality there begins 3:18, right?
3:18 Eastern time, yes.
Mm-hmm. Eastern time, and max totality 3:20, and it will end at 3:21.
Right.
So
they're a little under 4 minutes there.
Yeah, so they have some time maybe for the weather to change. What do you think? If you were a betting man.
From what it looked like earlier, it looks pretty thick and gray to me.
Oh no. Okay, so let's talk about this phenomenon, the 360-degree sunset. Oh, here we're back now in
Mexico,
in Mazatlan.
So let's see, they should be just about there, a couple minutes. So why isn't everyone looking up?
Well, they're starting.
Oh, some of them are looking up.
I think we have a little bit of time, right? Yeah. They're starting. Looks like a warm, sunny day.
12:51, so they should see the moon just being able to take a little bite out of the edge of the sun.
Mm-hmm, mm-hmm. Okay, let's talk about a 360-degree sunset. David, what can you explain? Oh, I should just remind people that who I'm talking to, because that's important. I'm talking with David Helfand, who is a professor of astronomy at Columbia University, and we are super grateful to you for all of your expertise. You've seen 3 total eclipses so far, and you've taken this opportunity, instead of chasing it, to come into our offices and talk to us about how magical they are. So the 360-degree sunset is what?
Well, so normally when you see the sunset, obviously the sun goes down in the west and the sky is bright there, sometimes yellowy, red, or whatever if there are clouds. But on the opposite direction, it's dark already, right, because the sun's not there anymore. So you see a definite gradient going around the horizon of light where the sun just went down to dark on the other side. But here, of course, the sun's high up in the sky. It gets covered up by the moon. And so you get that effect all the way around. It's completely symmetrical. And so you see that beautiful sunset kind of colors and everything all the way around 360 degrees.
Oh, it's like being inside a marble or something.
Right.
Wow. Okay, that's interesting. Which is another thing I think to think about. We got a lot of questions, and there were several reports out there about how to take photographs of the eclipse. And several people said, "Oh, just pay attention to the eclipse. Don't bother trying to document it. There'll be so many professional photographs," which is true. But another interesting point was take the pictures that are around you. You know, some in the opposite direction, or pictures of people looking upward, and try and document the moment.
Yeah, the few minutes of the totality go by very quickly, and they are very special. And so I've never even attempted to take a photograph. As was noted, there are many professional photographs that don't come close to evoking the experience itself.
You've never taken photographs?
No.
Interesting. Okay. All right. Should we go back to some reader questions?
Sure.
Just a reminder, you can catch this on time.com. You can ask questions in YouTube or on Facebook. Just drop your questions in the chat. David will answer them. And all right, let's just see what we've got here. When was the last total eclipse and what path did it take? And I guess that's sort of a complicated question because they happen all the time.
They happen once or twice a year, usually. I believe the last one was off the northwest coast of Australia. There was an island off the northwest coast. You could actually see it. And that was a very unusual eclipse. It's called a hybrid eclipse because for part of the path, it's a total eclipse. And for part of the path, it's an annular eclipse. In other words, the moon is just on the edge of being big enough to cover the sun. And over the course of half an hour, as it moves across the surface of the Earth, it gets too small to cover up the sun. In other words, it gets too far away from the Earth to cover up the sun. So that was a unusual hybrid eclipse. But there's an eclipse roughly once a year around the Earth. At any given location, the average, and the average has a very broad range, but the average is 375 to 400 years if you sit in any one location. So any given human life will not see an eclipse unless they travel, right?
Oh,
Typically.
interesting.
But there's
But New York keeps...
There's a lot of variation, yes, exactly. And New York is in a lucky period. It won't continue, but it's in a lucky period now because we had one in 1925. We'll have another one in 2079, which is only 150 years or something like that. And then there'll be another one after that in 2144, which is only another 120 years. But our poor friends in Los Angeles are much less lucky. They had one in 1724, and the next one won't be until 3290. In other words, 1,500 years between the next eclipse and the last one in Los Angeles.
Okay, wow, that's a big difference. All right, another question here. Does the eclipse have any effect on the Earth's gravity?
No. Yes, no. Well, I was going to say the atmosphere in the path of totality will cool suddenly because it's not getting solar radiation anymore. And that will condense it a little bit. And that can produce what's called a gravity wave, but it's not a gravity wave of the gravity that keeps you in your seat. It's an atmospheric phenomenon that's of minor significance, but detectable. But the Earth's gravity is determined strictly by its total mass and its radius, and neither of those change as a consequence of the moon covering up the sun.
Someone asked, do the corona flares affect Earth?
Yes, well, that's what we were talking about, the Carrington event earlier. The main effect we get most of the time from the standard sort of modest-sized solar flares is the northern lights, the aurora borealis, and the southern lights, the aurora australis, which most people in the northern hemisphere don't even know about, which are the colorful dancing lights you see if you're in far northern Alaska or Canada or
Have you seen
Greenland.
them?
I saw the northern lights from Massachusetts when I was a kid because there was a particularly violent solar storm in the 1950s, and the northern lights came as far south as New England. In the Carrington event in 1859, the northern lights were seen in the Caribbean, which was another indication of the extreme nature of that event.
Wow, that's incredible. Okay, and then here's another question. Oh, what will the eclipse look like from space?
Ah, that's interesting. If you're in the space station, for example, orbiting the Earth, you can see the shadow of the moon on the Earth, as we saw in the animations here. And you can actually see that shadow racing along at 1,500 miles an hour as the moon, sun, and Earth change their relative positions.
I guess, will you see, I guess it depends where you are.
Well, you'll see it whether it's cloudy or not, too, because the shadow will project onto the clouds as well as it projects onto the ground. So if you're above the clouds,
oh, that's a good point.
You can see the shadow.
Oh, yes, and there are people in an airplane actually traveling the path of totality.
Yeah, this is another kind of rather expensive way you can see an eclipse, and you can make it last longer because, of course, the plane flies along at 600 miles an hour, and so you can chase the eclipse and make totality last longer.
Okay, what does it look like from an airplane? Because you could be above the clouds, so that really...
You'd be above the clouds, so that solves that problem. Well,
Yeah.
the eclipse looks exactly the same.
Yeah.
It's just there's no clouds in the way. So when you're looking at the sun, you see the sun covered up in the
That's got to
corona
be quite
showing.
dramatic, right? Oh, here, let's take a pause. Here we are. This is actually Kerrville, Texas, I think, right? And this is the NASA live stream, not Mazatlan, right?
So you can see the clouds drifting across the surface of the sun there. So Kerrville, Texas, I think is still got a little way to go. I don't know where Kerrville is, but probably another 10 or 15 minutes until the moon takes a bite out of the sun.
Yeah, that's pretty cool. I wonder if that's a telescope feed from NASA.
This is certainly a telescope feed, and the black spot you see there?
Yeah?
That's
Wait, where is that? Tell me.
Up here.
Just in the center of the sun there?
Above the center.
Uh-huh.
That's probably a sunspot, which is a consequence of this eruption of the magnetic storms through the surface of the sun.
Interesting.
So it's where the flares arise.
Where are the flares rising? I mean, there's just one? Is that, or one
Well, that's
visible?
a little surprising. There's one, I mean, that's a big one. There's another one down here you can see.
Oh, yeah.
On the left side, about 3/4 of the way towards the edge. I can't see any others at the moment, but there are probably fainter ones that are there.
Okay. Right, that's pretty incredible. And is that in Kerrville that hasn't, I guess, the partial hasn't
started
begun?
yet.
So
Hasn't
we're
started
just,
yet.
that's a
No,
cloud.
That's the cloud. We wanted those to go away.
We did. Yeah, but still it's quite pretty, isn't it?
Now, see, you can see it changes the color, and the reason, this is not good at all. The reason it changes the color is because the light is being scattered and absorbed by the air molecules and the water molecules in the atmosphere, in the clouds, and they scatter the blue light most effectively, which is why the sky is blue, and they scatter the red light least effectively, so the red light gets through, and that's what changes the color from yellow to red.
Okay, explain why the sky is blue.
The sky is blue. The sky is blue because the wavelengths of light that come from the sun range from, that our eyes can see, range from 360 nanometers or billionths of a meter to 720 or so nanometers. So a single factor of 2, all the little waves that come in. And the red waves are longer wavelengths, slower, lazier waves. I mean, they travel at the same speed, but they wave up and down slower. And they can get right through the atmosphere to the ground just fine, as can the orange ones and the yellow ones and the green ones. But the shorter in wavelength you go, the more likely it is that they're going to be bouncing off some air molecule or other particle in the atmosphere and being scattered off in some other random direction. So all the light you see from the blue sky is sunlight. It's all sunlight coming from all directions. But the blue light is scattered around and so can come at you from any direction, whereas the other light comes directly to your eyes.
Okay. Thanks for answering that. Parents everywhere are grateful for that. Okay, I think let's cue up another clip. We have a 2017 satellite clip that shows the shadow over the U.S. Via satellite. And I guess this is sort of what
you were talking about.
What we were talking about.
See, zap right through.
In terms of what you would see from space.
Yep,
is that right?
There you go. So you see here that the shadow looks very wide, and that's because you're seeing partial and total eclipses together, but it's right through the center of that it's blackest.
Okay, and this was the 2017.
This is 2017, so it came on the coast in Oregon and went through and went off in Carolina. And I was up here in Idaho, right there.
Oh, right. The Sun Valley step down, right? Where you had to drive to, look at this.
There you go. Oh. So we said
what are we looking at here? This is Mazatlan, and this is, what do you call this moment?
Well, when they first touch, it's called first contact, but it's clearly gone past first touching about 10 minutes ago. And so it's gradually moving over the surface of the sun. And by the time we get to 2:07 Eastern time, so another
hour
or so, it'll be directly aligned. You can still see that big sunspot there and this little one down here.
Right, and again, this is the NASA feed, but this is so exciting, right?
Now, I don't know if this is from a plane, which is why there's no clouds.
Good question. Because there were just before.
There were some wispy clouds. They were fairly thin, but well, no, the other clouds we saw were from somewhere else. Right?
Oh yeah, you're right. That was Texas.
That was Texas.
Oh, so yeah, maybe it's just clear.
Could be.
And so this changing, it looks like it's maybe frozen a little bit.
This is what you would see
that's
if
what,
you had
oh,
your
whoops,
glasses
that's not
on.
what you would
That's
see.
not
We
what
just
you
lost
would
that feed. Okay.
Now we're back with the cloudy place. Ooh, no.
This is Kerrville, Texas. Right. There's still time, though. Don't lose all hope.
Well, there's still holes too, clearly.
Yeah.
I mean,
and that's the other question I was going to ask. Right, the clouds are moving, right? So it could sort of ebb and flow if you're
absolutely.
If you're not entirely lucky to get a full clear.
Well, that was my story about France, right? We drove around looking for a hole in the clouds.
Yes, right. Tell that story again, just to give people some hope. And actually, that is my question. Well, see, this is a big traffic nightmare. You don't. I mean, I imagine people are jockeying about and trying to find a better position. But could you? How far in either direction could you move, and how do you know sort of where to go?
Oh, well, you typically don't know where to go. It's pretty random looking for holes in the clouds. I mean, the eclipse path is about 100 miles wide. So if you were planning on being at the center of the path, you can't go more than 50 miles in either direction. You can go along the path, of course, but not across. And yes, it's a traffic nightmare, and I suspect, practically speaking, it wouldn't work. We were in rural France, and there were a bunch of people out looking for the eclipse, but it wasn't a traffic nightmare.
Yeah. I heard several stories about traffic nightmares, and including a crucial piece of advice to make sure you have all the essentials, including lots of snacks, should you get stuck in traffic.
That's absolutely right. I told several people that who were... One of my colleagues was saying, oh, yeah, we're going to drive up to Plattsburgh Monday morning. I said, no, you're not. The thruway is going to be a parking lot.
Yeah. Right, which is why in an earlier report we had a story about a school district in Pennsylvania that just gave the kids the day off because they knew it was going to be so crowded. But that's pretty special. That will be something you won't forget, I imagine, to see a total eclipse.
As we say, they don't happen very often. So.
Right. Not in your own backyard, that's for sure.
Exactly.
Okay, let's make our PSA again about making sure you're not looking at the eclipse without proper solar eclipse glasses.
Correct.
And if you don't have proper solar eclipse glasses right about now,
you make a pinhole camera by using your fingers in a tic-tac-toe pattern, by taking out a slotted spoon or
a colander,
or just a piece of paper with a hole punched in the middle of it. You put the sun over your shoulder so it comes down through the hole, and it'll project onto the surface of the ground or the sidewalk or another piece of paper you put there, the image of the sun. I think they've zoomed in on the sunspot. I suspect that's what it is, because sunspots have a north pole and a south pole because they're magnetic, just like the Earth has a north and south magnetic pole. And so there's usually two imprints.
Are you kidding?
No.
Right, no. Wow. Okay, well, that's a sunspot as seen from a NASA telescope in Junction, Texas, right?
I guess.
And is that moving about the surface of the sun, or it's in one place?
It's in one place. The sun is rotating, but I said it takes 26 days, so it takes 13 days for the sunspot to cross the surface of the sun. The jitter you see is the jitter of the telescope.
I see. Okay. And those are the solar flares. Ooh, what's this?
This is probably a picture in some wavelength your eyes can't see that's showing some of the consequences of this magnetic eruption through the surface of the sun.
Right. And let's talk again about the magnetic eruptions through the surface of the sun, just because I think people are interested in that. And you had, oh, wow, that's a pretty good image.
There we go. See, so that was that one. I don't know where these came from. I don't know that that's a current picture, actually.
Yeah, maybe not. San Diego, huh? It says live.
Oh, it says live.
Yeah. So the solar flares are what? Just explain that.
And you see this.
Oh, yeah, that's what they're seeing.
Yeah.
Oh, yeah.
Now, they're only going to get something like, what, 50% or something.
In California.
Like that, in California, yeah.
Right. And it looks very different than what we just looked at from Mazatlan, right?
Right, because you're looking from a different
right.
geometry.
Right. Yeah, that's kind of amazing. It would be a cool contrast to see all the different places, right? The angles of Earth.
The solar flare, you want to go?
Yeah, tell me more about the solar flares.
So again, the surface of the sun that we see is the coolest part of the sun. And above that cool surface, there's a pretty violent atmosphere that's threaded with magnetic fields. And they accelerate particles to very high energies, which means instead of emitting visible light that our eyes can see, they emit ultraviolet light and X-rays. So while the sunspots look dark here, and you might think, well, that must mean they're cooler or they're not emitting light, they are emitting light, they're just emitting light that your eyes can't see. And in fact, when there are lots of sunspots, when the sun is active, it's when the sun puts out most of its energy, more energy than when it's passive. It does this in an 11-year cycle, and the change is about 0.1%, or 1 part in 1,000. So
Where are we in that cycle?
We're about a year from the peak of that cycle. So the sun is, in other words, brightening in the sense that its total energy output, not the part we can see, but the total energy output is slightly higher by close to 0.1% than it was 5 years ago.
Tell me about something that I read about the moon moving further and further away from Earth, and what that will mean for events like this. Of course, not in our or anyone we know's lifetime, but...
No. So the moon is orbiting the Earth, and the Earth is spinning on its axis. The current configuration, where the moon is 238,000 miles from Earth, is not static. The moon is currently moving away from the Earth, and we know this both because we understand gravity, but also because we've actually made the measurements. The Apollo astronauts in 1969 and 1970 left little reflectors, little mirrors, on the surface of the moon. And we now shoot lasers from telescopes on Earth to those reflectors. The light bounces off them just like it's a mirror and comes back. And by timing the time it takes to get there and back, we can measure the distance of the moon to about 1/4 of an inch. And what we see is that the moon is systematically moving away from the Earth at about 1.5 inches per year, which is about the rate at which your fingernails grow. If you don't cut them for a whole year, they'll be about 1.5 inches long. So that's the rate at which the moon is receding from the Earth. The reason for this is that the moon's gravity interacts with Earth, in particular the oceans on the Earth, and raises tides. As you know, there are 2 tides a day. The Earth spinning on its axis under those tides produces a friction, and that slows down the rotation rate of the Earth. So the rotation rate of the Earth is actually systematically slowing down, and to compensate for that, the moon is moving slightly farther away. Now, we know this is true from the fossil record as well, because 300 million years ago, we have fossils of corals, and corals show bands, like trees show rings, that are annual, but they also show daily fluctuations as a consequence of the tides, because of course they live in the ocean. And we can see that 300 million years ago, the day was only 22 hours long, and there were 390 days per year, because of course the time it takes us to go around the sun hasn't changed. And so days were shorter. And because the Earth has been systematically slowing over that time since the dinosaurs came into being, and the moon is moving farther away, the Earth's slowing and the moon is moving further. And as a consequence, in a long time, hundreds of millions of years, the moon will have moved sufficiently far away that there'll never be a total solar eclipse, because the moon, of course, is not going to change size, the sun's not going to change size, and as you get farther away from the Earth, the shadow will never reach the Earth.
You can't eclipse it. It can't eclipse it, right?
So there'll be annular eclipses where the moon covers up the center of the sun, but you see the sun all around the edge.
Does it mean the days will get longer too?
And the days are getting longer. They are getting longer.
They are?
Yes.
It's not just my own weariness.
No. Not such that you'd notice they're getting longer, but they are getting longer by tiny fractions of a second per year, yes.
Wow, interesting. So what does that, I mean, wow, that has some long-term...
Well, the really long term is fascinating, because eventually we'll get to the point Whereas today, the moon has one face towards the Earth, and we never see the backside of the moon. It's not the dark side of the moon, Pink Floyd notwithstanding. It's the backside of the moon, right? Which is fully illuminated at the new moon, like today, right? It's the other side of the moon. It's illuminated. That looks black. The side we see looks black because the sun's on the other side of it, right?
Okay.
And then as it goes around, 2 weeks from now, we'll have a full moon, and that's our side of the moon is illuminated. But that same face of the moon stays facing the Earth all the time, and we don't see the backside.
We don't see the backside.
The Earth, of course, is spinning once a day underneath it, so the moon gets to see all of the Earth. However, as this process goes on and the Earth slows down and the moon moves farther and farther away, eventually will lock such that the Earth and the moon will only see one face as they go around. And as a consequence, the notion of a honeymoon will have a new concept because you'll have to go all the way around the Earth to see the moon at all.
Oh.
Because the moon won't be visible from half the Earth.
Wow.
But sufficiently long in the future that we won't be here.
Billions?
Billions, yes.
Okay.
Billions of years.
Shall we not worry about that today?
Yeah, that's one thing we don't have to worry about.
Okay. Should we talk a little bit about insolation, which is different from insulation? But what is insolation? I think we actually even have a video clip of sort of what the insolation will look like, which we could show. But I must admit that's not a word that was in my repertoire.
Well, the only difference between the two words is sol, S-O-L, in the middle, which means sun. Right?
Yes.
So insolation is the amount of energy we receive from the sun.
Okay. That's what we're looking at here. This is the expected, I suppose.
Oh, this is today's, I guess. I see.
Okay, there goes the sun.
And here you see the shadow.
Yeah, and the insolation.
Moving across. So insolation is just the total energy reaching the Earth from the sun at any given time.
Which just means it gets cooler? Or what?
Well, as the insolation goes down, it gets cooler, which is why it's cooler at night than it is in the daytime, because we're not getting any energy from the sun on our side of the Earth at night. But this affects the seasons as well, of course. Because the Earth's rotation axis is tilted by 23.5 degrees with respect to the plane of its orbit around the sun. In the wintertime, the sun is directly overhead in the southern hemisphere and comes in at a very slanting angle in the northern hemisphere. So each square meter of ground gets much less energy.
Right.
Whereas in the summertime, not at our latitudes, but say in Florida, the sun is directly overhead and as a consequence gets the full solar insolation. So it just depends on the angle of the sun in the sky as to how much energy is received by each square meter of Earth. And that is what determines globally, with storms and things like that taken into account, what the temperature is.
But an eclipse is just a matter of hours.
So in an eclipse, well, a matter of minutes.
Minutes, really, yeah.
The insolation drops to zero, or close enough to zero. And that's why you literally feel it get cold outside. I mean, and temperature can drop by 5 or even 10 degrees.
But that's not a huge effect on any life form or...
No. As I said, cooling air is denser, and so that will change the pressure across the eclipse path, so you might get a little breeze that blows in from warmer areas to fill in the colder areas. But as soon as the sun comes back again, 4 minutes later, it's receiving the full amount of energy. So.
Right. And what about the grid? What about solar panels that would, lose sort of the sun's panel power?
Completely lose power, yes.
Yeah. Is that a concern?
I don't think so. Again, the time scales are very short. The solar panel array will reduce down to close to zero at the moment of totality and then gradually build up again over the hour when the moon moves away. But most people's systems have batteries that allow them to smooth out those things, because clouds drifting overhead do the same thing. Right?
I was going to say, right, what's the difference?
Oh, a cloudy day, you only get about 10% of what you get on a sunny day out of your solar panel.
And during an eclipse, with the 4 minutes, let's just say,
You'll
of
get
totality
zero.
aside, when it's partial, it's a sort of akin to a cloudy day?
Exactly. I mean, if that much of the sun is covered up, you're going to get 90-some% of the energy you'd normally get.
Mm-hmm, mm-hmm.
Where are we now? Oh, this is still in Texas. Oh,
Yeah.
so that's good. The clouds are gone.
Yeah, that is good.
Oh, no, they're still there, but
But still, I think it adds to the drama. I like it. Yeah. How did you become an astronomer? What led to your career choice?
Oh, well, I guess it's a testament to liberal arts education. So
Really?
I went to college convinced I was going to be a theater major.
No.
Yes. And I actually attribute 70% of my success in life to my theater major, since most scientists aren't great at public lecturing, and I have some skills at that. And also, when you're a theater major, of course, you have to write a lot of papers, which have to be succinct, trenchant analyses that are persuasive of your point of view. And when you're a scientist, those are called proposals, which gets your money and telescope time. And so those two skills have been extremely important to me. But I don't actually remember why I took a course in astronomy, because I had no interest whatsoever when I was a kid. 95% of my astrophysical colleagues had built telescopes by the time they were 10 years old. You know, they were really into it. I had no interest whatsoever. So I probably took it as a consequence of a distribution requirement in a liberal arts college. And the professor was not very good. In fact, he was so bad he was fired for being a bad teacher. Doesn't happen anymore, but it used to happen then. But I became fascinated by eclipsing binary stars. So it turns out our sun is very typical in terms of its age, its temperature, its size, its mass, its chemical composition. But there's one difference, and that is most stars have companions. Most stars are in pairs or triplets or even quadruplets or quintuplets, and they orbit around each other. Many stars also have planets like our sun has, but they usually have another star. So when two stars are orbiting each other, if you're aligned appropriately, one star will pass in front of the other, and as is happening here with the moon, block that star's light. And then half an orbit later, the first star will block the second star's light, right?
Uh-huh.
Now, you can't see two stars because they're far too close together. We're so far away that you can see a single point of light. But that light gets dimmer and then brighter again, and then dimmer and then brighter again, just like the eclipse is going to make the sun get dimmer and then brighter again, right? And
as each star is being eclipsed by the other, its twin,
right.
Okay.
And as a consequence, from just looking at that dimming and brightening and dimming and brightening, you can determine to fractions of a percent precision the masses of the stars, the radii, the diameters of the stars, the structure of their atmospheres, their departure from spherical symmetry, the chemical composition of the stars, the origins of the stars, the fate of the stars. You can determine everything about the life story of these two stars. And I found this fascinating. So we had to write a paper at the end of this, again, liberal arts college, right? You write a paper in a science class. So we had to write a paper. It was supposed to be 8 pages long, and mine was like 38 pages long because I became so obsessed with these eclipsing binary stars.
Oh my goodness, you tapped into an overachiever self.
Yes. And then, so I guess I was sufficiently captivated. I thought, well, I'll take one more course in astronomy. It can't hurt me. And there I had a spectacular teacher. She was from Germany. She was the first female professor in the physical sciences in Germany. So she was about 5'1", but she was tough.
Mm-hmm.
And she made us actually do astronomy. Now, this was way before CCD cameras, so you needed photographic glass plates and photographic film, and you had to develop the film and do the measurements and all this other stuff. And the last day of class, when we had done all this, just a class of 8 people, she said, "So, I think it is time we take you where astronomy is done." And she passed out 8 plane tickets for all of us to go from Massachusetts to Arizona for the month of January to see all the telescopes and meet all the astronomers and observe and all this other stuff. And the last day...
That's a field trip.
That was a field trip. I never did find out if she paid for that herself or whether she actually got money from the college to do it. But anyway, she was wonderful. And the last day we were driving out to the observatory at night with the director of the observatory. And I was in the back seat, and he said, "So is anyone here thinking of becoming a professional astronomer?" And I'm thinking, this is pretty good. I said, well, I maybe consider it, you know. And so he said, okay, so suppose you're called to testify before Congress, which is ironic because as president of the AAS, I was called to testify before Congress 40 years later. And you have to justify spending public money on this completely useless profession because, I mean, what are the practical applications? Zero, right? And so it was during the Apollo program, and I said, well, you know, there's miniaturization of computers, that's going to be important, which turned out to be true. And there's Tang, you know, there's powdered orange juice, yeah, that's probably important. And he cut me off and he said, no, there's maybe spin-offs, there may not be spin-offs, but that's not a justification. The justification should be the same as that for supporting symphony orchestras and opera companies and poets, because it distinguishes us as human. And I thought, gee, I like that. I could do a profession that distinguishes us as human. And so I became an astronomer in the backseat of the car that night.
I might cry. Because I feel that is so full circle. Everything I read about witnessing an eclipse is a reminder of our shared humanity and our place in the universe.
Yes, I think human curiosity is one of the most important attributes of our species. Unfortunately, our education system is not ideally suited to foster it, rather it usually suppresses it. But people can still be sparked by things like eclipses to recognize their place in the world and their connection to it.
Right. Wow, how interesting. I wonder how many young people will experience this eclipse and have a career change as well. You chose the bright lights of the solar system instead of those of Broadway.
Yes, and I must confess that my wife, who started on Broadway when she was 6 years old and worked for 35 years in television and Broadway, assures me I would still be waiting tables if I had stuck with my theater career. So probably just as well I made the switch.
Well, we should all be so lucky to have a professor who is so both entertained by his chosen subject and entertaining in explaining it to us. Okay, so just back to what we are looking at. This is a feed from Sky Show, which also has a special telescope, and they actually provide services to NASA for launches and such, and they have offered us this feed from Arkansas, which is pretty great looking.
So it's got some clouds, but it's not too bad.
Mm-hmm. Yeah, thank you to Sky Show for that. Oh no, my goodness. They're going to be in Vermont as well, I think, later in the day. Yeah, these are their special telescopes and tracking system, which they developed for NASA launches and re-entry imagery.
I see. This is a different place, though, because the moon's already
Yeah, you're right.
making progress here.
This is a different feed. The moon is making progress. Oh my gosh. Look, it's so dramatic. So if you were on the ground, I mean, this must be Mazatlan, right? Don't you think?
I think that's not the direction the moon was coming from at Mazatlan, actually.
I think the feed is in and out because of the clouds.
Yes, it is.
Right. Here we are back to Sky Show. And again, that's a telescope feed.
So should we talk about some of the historical eclipses that
Can we?
made an impact? Sure.
Yeah. You tell me.
Well, the first record we have is from a petroglyph in Ireland, at one of the megalithic things in Ireland, built roughly the same time as Stonehenge, maybe a little earlier even. And it's from November 30th, 3340 BC. So that's a long time ago. There's no, of course, written record, but there's a petroglyph that appears to show the moon covering up the sun. In 2334 BC, there was a famous eclipse in China, but the two court astrologers, Shi and Ho, had a little too much Moutai, and so they failed to predict this eclipse, and the emperor promptly beheaded both of them.
Okay.
So it was a pretty tough job to be an
Wow.
astrologer in the Chinese court, I guess. In 1178 BC, April 16th, it's probably the eclipse that Homer wrote about in the Odyssey. It would have been 4.5 minutes, just like this eclipse here in ancient Greece. In 585 BC, the Lydians and the Medians were in the midst of a 5-year war, slaughtering each other. And during one of the battles, a full total eclipse occurred, which so awed them that the fighting stopped and they forged a peace treaty as a consequence. So eclipse can be peacemakers. And then in August of 1868, which is one of the first times the corona was studied in detail, it was recognized by both a Frenchman and an Englishman that there was a particular signal of, we call them lines, of the spectrum of the sun, which didn't correspond to any of the known elements in the periodic table, most of which had been filled in by then. And in fact, they gave it a name, and they called it helium, after Helios in Greece. And of course, helium is the second most abundant element in the universe, and we never recognized it on Earth. It was first discovered in the sun.
During an eclipse?
During an eclipse, right.
Amazing. Amazing. Those are great stories. Okay, let's, David, I have a few more questions for you.
Good.
From our viewers. Okay. A lot of these are about glasses, which makes sense because people are getting ready to go outside, and we want to remind you, you must use proper eclipse glasses, right? Are paper or plastic glasses better?
It doesn't matter. All that really matters is the material that you're going to look through. That's what's critical. It doesn't matter if they're paper, plastic, or metal, or whatever they are. And you must make sure that you can't see anything else except the sun through those filters. Mm-hmm. And if that's true, then you're okay.
Mm-hmm. Yeah, so you really want to use proper eclipse glasses, and not sunglasses, not sunglasses, not sunglasses.
Oh, definitely not sunglasses. Mm. In 5 to 7 seconds, you'll destroy your vision.
Don't do that, please. Okay, why is it, we talked about this a little earlier, but let's do it again because I think it's important. Why is it more dangerous to look at the sun during an eclipse?
Well, it's not more dangerous to look at the sun during an eclipse. It's just that you wouldn't bother to look at the sun any other time.
Your eyes won't really let you look at the sun because your brain has a shut-off valve.
That's right. But the point is that even when the moon is covering 90% of the sun, the amount of energy the sun is putting out and is entering your eyes is too great for your eyes to withstand.
Yeah. I did read a story, actually, about a doctor who saw a burned cornea that had, like, the crescent shape in it from someone. I know, it's terrifying. So don't mess around with this stuff, people.
Don't mess around.
Okay. And then, apropos of that, I suppose, can you use a colander to look at the eclipse? We should explain how and what and a colander for looking at the eclipse really means.
A colander is great because you can see 20 or 30 eclipses. Mm. What you have to do is hold the colander up with the sun over your shoulder.
You hold it in front of you.
Hold it out to the side. Well, not in front of you,
okay,
then the sun won't get to you, but to the side. And have it project onto some clean surface, a sidewalk or a deck or a piece of paper you can put on the ground. And each of the little holes will act like a pinhole camera and provide you a photographic view, if you will, of the eclipse.
Great. Okay, this is our last question, and then we're actually going to cut to a live feed from Mazatlan. Can my 3-year-old watch it using the regular eclipse glasses?
As long as you make sure, I mean, the spacing of the glasses isn't too wide for their eyes. And you must make sure the filters cover the eyes. But then it's perfectly fine.
I did see a really cute little thing on YouTube, a crafts project where you could mount the eclipse glasses onto a paper plate to cover more of their face, which is something to think about. That might add protection.
Well, the main thing is the spacing. If their eyes are closer together than your eyes, which I think little kids' eyes are closer together, then the adult glasses might not fit.
Yeah.
The important point is to make sure the filters that you look black are covering her eyes, and then it's fine.
Okay, great. I am so grateful to you for your time, Professor David Helfand from Columbia University. Your insight and your personal stories have really made this so fun for me. I hope you'll come back for our next big solar event.
Celestial event.
Celestial event, thank you.
Well, it's been my pleasure entirely. Thank you.
Yeah, great.
other solar systems. Who knows what else is happening out there, but this is the only one that we know of, and so I think that just makes everyone so thrilled.
And just like really quickly, what are some of the next total eclipses that people can look forward to?
Well, in 26 and 27, we're going to have to cross the Atlantic. Everyone's going to have to be on the either Greenland, Iceland, parts of Spain, Northern Africa. Those are going to be some really good ones coming up. So
that's in 2026, isn't it?
Yeah, 26 followed by 27 in Northern Africa, Morocco, Egypt, if you want to catch the pyramids at the same time. So those are really going to be good ones. But the next coast-to-coast U.S. eclipse, you're going to have to wait to 2045.
All right. Well, thank you so much, Marcia. That is all the time that we have for now because we have an exciting guest to speak to over in Canada. So we're going to throw it over for a chat with a Canadian astronaut.
Here, 138. Time to join us. Just to tell me a little bit about what we could hopefully expect to see today.
So obviously we'd love to be able to see the sun and the moon passing in front of the sun. Looks like the clouds are going to stop us from seeing that, but we are going to experience totality here regardless. It's going to become nighttime. I've never seen a total solar eclipse, so I'm excited to experience it myself, but speaking with other people, I think we're still going to see some of the cool effects where the lighting is going to change here. It's going to get very dark, but as we approach and get into totality, look at the colors. Different colors are going to show up differently. We may see different lighting effects on the ground. Observe the environment. See what nature does. How does nature react in this moment? It's going to throw them off a little bit. So these are the things I'll be watching for, even if we can't see the sun because of the clouds.
That's going to be pretty exciting. You're an astronaut, and you are looking for this. That says something about us, huh?
Oh, it's a unique experience in my lifetime. First time I see it, for sure. I think it's just a fun experience to get outside together, have some community, talk about science, how it affects our lives. I think it's a really important conversation today for people to understand that science is nothing more than us just trying to understand what is fact, what is fiction. We don't have all the answers yet. Part of science is asking the question and then trying to finally get to a conclusion. Science is something to be embraced, and it's important for our future here on the planet.
And science is a big part of what happens next year for you. Talk to us about what happens for you next year.
So I feel very fortunate. About a year ago, I was assigned with the Artemis II crew. We're going to fly a new rocket, the Space Launch System, the Orion capsule. First time we put humans on this, and the crew and I, it's Reed Wiseman, Christina Cook, Victor Glover. We're going to, 3 Americans, 1 Canadian, and we're going to take that capsule, fly it around the moon, and bring it back and get it ready for future Artemis missions where humanity will walk on the moon once again. And we're doing this as an international collaboration, which is an extraordinary example for the world right now.
You mentioned that hope eventually we go back to the moon. Every little bit counts in this.
Oh yeah.
Right? It takes public support. You see behind you, this is public support, right? Talk about how important that is that people kind of get behind going back to exploring to space.
The overall sentiment that the crew and I have felt since we announced the Artemis II mission has just been overwhelmingly positive. People are inspired by exploration. I meet young Canadians and Americans all the time, and they are fired up. They want to know how they're going to be able to participate in exploration in the future. And I think there is more of a common understanding now that when we push ourselves in places like space exploration, the benefits do ripple back down to our lives here on the planet. Even today with this eclipse, we're going to leverage this opportunity, NASA, Canadian Space Agency, to study this. We'll learn new things about space weather, which affects how we're communicating right now. And so there's just, science is something to be embraced, but also just to remind our children that we, as a global population, can do extraordinary things when we set big goals and we come together to accomplish them.
Well, I'm going to throw to our colleague Kyle down south. Hopefully he has a better view of these clouds and maybe gets to see it entirely. But I appreciate you taking the time to talk to us.
Yes.
And we'll go back to Texas.
Yes, wonderful. Happy eclipse, everyone.
So there are so many exciting exciting things happening today, not just for the people across the path of totality, that's just a narrow band, you know, across North America. So much of North America is actually experiencing a partial eclipse right now. And you know what? There are so many experiments, like for example, if you have household items like a colander or a cheese grater, you can, if you're underneath some partial eclipses, take a look how strange the shadows are at the moment. So here in Mazatlan, it's kind of hard to see, but here in Mazatlan, all right, up above us, you know, as the clouds are clearing up, we're starting to see the partiality, and it's impacting, you know, the way that shadows are being cast on the ground. And it's kind of hard to see here, but if you take a look at the shadow cast by the cheese grater that I've got on my hand, it's actually reflecting the eclipse. It looks like a shadow, you know, the moon is taking a bite out of the sun. So, you know, there's so much to do here. We're not just waiting for totality. We're really being excited about all of the things that everybody around the country can do at home safely and enjoy it with their friends, families, and so much more. All right. And with that, we're also at the moment, this is a testament to how fast weather moves in Texas. For example, just this morning it was completely clouded over with low-hanging clouds, you know, sort of not the ideal thing. Just a few meters behind us, a couple of blocks behind us, clouds are covering, but then the sun keeps speaking out. So, you know, there's just so much high hopes here, and we'll see how it goes. And that's probably happening all across North America right now. Lots of positive vibes. And so with that, let's take a look at how the rest of North America is preparing for their moment with the solar eclipse. Hello and welcome back here in Mesquite, Texas. Joining me now to dive into Solar Eclipse 101 is Leslie Barnhill, science educator at the Mesquite Planetarium. Welcome, Leslie.
Thank you. Nice to be here.
Nice to have you. So tell us at first, about the 4 phases of the eclipse. What are people looking forward to? What can they pay attention to?
Okay, well, there are 4 to 5 phases of the eclipse. We actually call them contacts. The first contact is when the moon comes in contact with the sun. That's when you start to see the moon's black disk come in front of the sun, and it's actually happening right now here in Mesquite. The second contact, or the second phase, is right before totality, and that's when the moon is almost completely in front of the sun, and you can see some really fantastic things like Bailey's beads, which are little beads of light coming from outside of the moon, as well as a diamond ring. And these are all little pieces of light that are coming from the sun through the moon's uneven surface with all the craters. So wherever the sun's coming in, we've got craters on the moon, and they are creating these beads, or this diamond. And that happens right during second contact. Then is totality, when it's completely dark, hopefully, if skies are clear, and that here is going to last a little bit over 4 minutes. And then our third contact is when it's similar to the second contact. It's when the moon starts to move away from the sun, and you may have the opportunity to see those Bailey's beads and that diamond ring. And then finally, the last 4th contact is when the moon is completely away from the sun, and it's over.
It's over. And we're expecting that to be about 3 hours total for most places, right?
Correct, yes. And we've got some clear skies, and we've already seen first contact, so I'm fingers crossed.
For those in the path of totality, where there's a break in cloud cover or are lucky enough to have clearer skies, what can they expect of their experience?
In totality, if we have completely clear skies, we can see some amazing things. First of all, the whole sky is going to darken to not just cloud cover, but completely night. With a cool thing that I have yet to see is a 360-degree sunset. So where usually we see a sunset on one side of the Earth when the sun goes down, since the eclipse happens, we should see a sunset around the whole horizon wherever you're at. That's if clear skies. If we do have clear skies, we should be able to see some of the sun's corona, which is the atmosphere around the sun, and that's right at totality. We should be able to see 2 of the 7 other planets in the sky. Most of the planets will be out, but 2 should be visible, and that's going to be Jupiter, that's going to be to the left of the solar eclipse, and then Venus, which is going to be to the right of the solar eclipse. Also, we should be able to see the comet. If you have a magnified view, filtered view, like binoculars with a proper filter on it, you'll see a comet that's going to be close to Jupiter. It's called 12P, and some people are calling it the Devil's Comet or the Mother of Dragons. It's exciting. And then also there's some stars and some constellations that clear skies you might be able to see. The Orion main stars, Betelgeuse and Rigel. You might be able to see Aldebaran, which is part of the Taurus constellation, as well as Capella, which is part of the Auriga constellation, which is the goat herder, which I think is kind of cool.
Oh my God, that's phenomenal. I feel like you'd be really lucky if you were stood next to an amateur astronomer or any educator near you. So if you're in a place where you're watching with a watch party, go find the scientists in the space, the educators. They've got a lot to share. Now, I know that there's a lot of scientific words being thrown around. Can you just share what is the difference between what is called a penumbra and the umbra?
Okay, the penumbra and the umbra, they are different parts of a shadow. And since the solar eclipse is dealing with 3 spheres, you've got the sun, the moon, and the earth. All of them are rotating, all of them are orbiting. We're pretty much primarily looking at the moon and the sun orbiting. The shadow cast, the darkest shadow cast, is called the umbra, and that's the shadow that will give you a total solar eclipse. A penumbra is a little bit more diffused. You got a little bit of light, but it is still a dark shadow, and that'll give you a partial solar eclipse. What's cool about this, a total solar eclipse, is the umbra has to actually, the tip of the shadow has to hit the Earth, and that usually only happens when the moon is close enough to the Earth, because the moon's orbit is not a complete circle. Sometimes it's a little bit closer to it, sometimes it's a little bit further. So that's why we're going to see a total solar eclipse, and it's going to be longer.
So I've also heard that because the moon is closer, is it because it's closer to the planet or further away from the planet that we're getting a longer time of totality than in 2017?
Yes, it's because it's a little bit closer to it. It's in its perigee, which means it's closer. Its apogee means it's further. And an apogee will give you an annular eclipse, which we had back in October. But it's close enough for that tip to hit Earth, and it's even a little bit more closer to have our path wider and giving us the longer totality.
And now, any last words about safety? Because I know everyone's been talking about how important safety when viewing the eclipse is, not just during totality, but especially wherever you are where you're seeing partial eclipses. So any words?
Yes, please, please, please wear your glasses when it is not a total solar eclipse. I tend to be on the safe side just because I have some older eyes and I want to save my eyes. You have the potential to have temporary or permanent blindness if you stare at the sun, even during the partial part of the eclipse. And it could cause things like blindness, it could cause things like distorted view, or even color changes. If you have any of those during this eclipse, please go see your eye doctor, because it's very important. You can take your glasses off during totality, but I kind of err on the side of caution. Wait until it is completely totality. If you're in the path of totality, you know the time. So go by your watch, wait a couple of seconds after it starts, and plenty of seconds before, put your glasses back on so you don't run that risk. Okay.
Great. Thank you so much for joining us,
Thank
Leslie.
you, Kyle. Appreciate it. Thanks.
All right, folks. We've got some... We have a lot of people already looking up at the eclipse because the sun is peeking out. Seriously, the weather here is just changing moment by moment, so we really don't know what's going to happen next. There's a lot of things to look forward to, but especially right now on Mazatlan, they're really closing in on the moment of totality. And you know what? It's the very first spot on North America, on the continent, where the umbra, the moon's shadow, is touching down. So we want to give you a special chance to take a look at it. Just listen to the experience of folks watching on the ground. So we'll come back after that. But for now, please enjoy the view from Mazatlan, Mexico.
Sombras, sigan proyectando sombras, sigan sintiendo, sigan teniendo atención a los detalles, a lo que está pasando. Esas nubes probablemente esperemos que se puedan retirar en el momento en que ocurra la totalidad. ¿Sí? Hay unos fenómenos muy interesantes con la atmósfera, porque va a pasar que la luna va a bloquear al sol y al bajar la temperatura puede ser que esas nubes se disipen, ¿vale? No es absolutamente seguro, pero vamos a ver. Okay, estamos cerca. Sientan el eclipse. Ya casi.
Mi mamá en Humberto, la edificación en la azotea. Yo me vine a partir de ser hermana.
estén atentos a lo que va a seguir a continuación.
Nos mandaron información a los medios, pero sí nos mandando. Rosario, Concordia. Aquí en Mazatlan es su totalidad. Y allá es Rosario, Concordia, Napa. Pues allá está registrado. Allá no va a ser su totalidad. No es cierto ni nada. Yo también saludé.
Estamos cerca, faltan 7 minutos para la totalidad. ¿Preparados? Ya casi, ya casi.
All right, folks, the weather might be iffy in many parts of North America today, but if you're lucky to have clear skies or a break in the clouds, there are some fun activities you can do at home to safely experience the partial and total solar eclipse. Now, here with me is Julie Greer, one of Mesquite's volunteer educators, to show us ways we can view the eclipse if you don't have eclipse glasses. So, welcome, Julie.
Hi, thank you.
So why don't you show us a little bit of the demos that people can do at home?
Okay, so one of the fun things, if you happen to be able to stand under a tree, you can look through the branches and you'll see the shadow and the different phases of the eclipse through the branches. So that's an easy one. And we're lucky enough that the sun is coming out. One of the other things that we've put together is a punch card, and you can hold it with the sun at your back on a shadow, and you can see the phases of the eclipse. Even though you see a square, a circle, and a triangle, when the sun is actually shining through it with the phases, you'll see the phases on the ground or even on your hand. So it's really neat to see the different phases through that.
So these are really handy, especially for young kids who, can't really wear the glasses perfectly on their faces,
Yes,
right?
Yeah, so that's one of the main things, is you don't want to look into the sun. So even most houses have a colander, so you can even show a colander on the ground, again with the sun at your back, and you can see, the phases through the holes in the colander. So one of the fun things that we've been doing at our booth is actually making a pinhole viewer, and it's super simple with cardboard, foil, and so you've cut the view part of it and you fold the foil over it. This is so easy. And then you take a toothpick. Sorry.
It's live TV, folks.
And then you just poke a hole in through the foil.
Just a small hole.
Just a small hole, a round hole, and again you'll see the shadow of the eclipse on the paper, on the cardboard.
That's fantastic. What are things that this is one of my favorite activities, like looking at the shadows. What gadgets at home, can people pull out of their kitchen or anything else?
So a cereal box, you can make a pinhole viewer out of a cereal box. I actually pulled this one off my refrigerator this morning. So, and again, you do it the same way with poking a hole in it and holding it up to the sun so you can see the shadow on the ground. We've got the tree branches is a good one, and the colander is an easy one to pull out of your kitchen.
Okay, how are you feeling about the weather here in Texas today?
I am so excited that the sun is coming out. It's a little bit humid, but we're used to that in Texas. We have every little, phase of the weather, but the sun is out, so people are starting to look up. It's really fun to see the different faces already.
And as an educator, how are you feeling about people's reactions to the eclipse, to the science, to the things that they can do?
It's been really fun. We've been talking about how the animals are going to react, and is it safe to leave your dogs outside, and how the birds are going to quit chirping because they think it's nighttime. And so it's been fun to Google and research some of that.
What has been like the biggest question people typically ask of you?
A lot of them are, why can't I just look up the sun? Why can't they, and so you get a sunburn if you sit out in the sun too long. So imagine looking directly at the sun with your eyes and the damage that it can do to your retinas. And it's not even something that you'll notice right away. It may be something that you notice a day or two later that you sunburned your eyes.
All right. Well, thank you so much, Julie, for joining us. We really appreciate it. And now I think we're going to throw it back to the views in Mazatlan and maybe or elsewhere around the country. So.
Ok, 2 minutos para la totalidad.
¿Con tu hija de Colombia?
Yo de aquí de Mazatlan.
Ustedes son los turistas de Colombia, ¿verdad?
Yo no soy turista de Colombia.
¿Quién es? Tú eres la colombiana. Después te voy a hacer una pregunta.
esa estrella? Es un planeta. ¿Lo vieron? Otro más. A la izquierda. Miren el horizonte. Vean cómo parece que amanece y todo el horizonte está iluminado.
Y mira el punto.
¿De dónde eres?
De Colombia.
¿De dónde de Colombia?
De Bucaramanga.
Bucaramanga. ¿Hace cuánto que llegaste aquí?
Llegué hace una semana.
¿Cómo te llamas?
Karen Ibarra.
¿Karen?
Ibarra.
¿Con Y o con I?
Con I latina.
Cuéntame, ¿qué es esto?
Buah, un espectáculo absoluto de la naturaleza. Vine a hacer una pasantía de investigación y me siento feliz de esta experiencia maravillosa.
¿Qué edad tienes?
Tengo 39 años.
¿Pasantía de qué?
Investigación en la Universidad Astronomy Prof de México con la doctora Ana Hernández.
Muchas gracias.
Bueno, a ti. ¿De qué? ¿Para dónde vas a hacer?
Espérate, creo que no salió nada.
Ay.
¿Tu nombre?
Karen Ibarra.
Karen Ibarra, con I latina.
Con I latina.
¿Qué estás haciendo en México?
Estoy haciendo una pasantía de investigación en la Universidad Nacional Autónoma de México con la doctora Ana Hernández. Soy investigadora científica del Eclipse de Max. Estoy alucinando en el eclipse.
¿Qué pasó? ¿Qué está pasando?
Ay, wow, que estamos de día, pero de noche también. Dos momentos en simultáneo, espectacular. Ver el anillo de diamantes es lo máximo.
Muchas gracias.
Bueno, a vos. Oye, Karen, ese puntico.
15 segundos para el fin de la totalidad. Hay que dejar de mirar cuando yo les dé la señal.
Una pequeña mordidita, el puntito, ahora ya se está desplazando y empieza a verse el anillo de fuego.
¡Se acaba la totalidad!
Nos colocamos los lentes, los visores, ya no es seguro observar el sol.
Ok, ahora continúa la segunda parcialidad. De aquí y hasta las 12:32 vamos a tener el fenómeno inverso. La luna se va a ir retirando hasta que a las 12:32 volvamos a tener el mismo sol de todos los días, el eclipse haya terminado y tengamos que esperar otros 3 siglos para volver a presenciar esto. Muchas gracias a todos.
All right. Oh my gosh, folks, have you seen that? Did you see, the eclipse touching down on Mazatlan all day today, this morning? Just the earliest forecasts were cloudy and potentially rainy, and just then you could see just how quickly the weather changes, just in time for that moment of totality. And even after totality, that moment when the diamond effect came in through, the Bailey's beads were peeking through, like, it just is so exciting, and I am living vicariously through them right now as the clouds start to cast a shadow on us instead of the moon. But you know what? There's just so much more excitement to be had, because we're going to head over to Carbondale, Illinois. Again, the weather's been so changeable throughout the path of totality, but sometimes, look, you just never know, right? Total solar eclipses happen every few years or so, especially like where it's usually on somewhere else like the South Pacific. So this is a really special thing that we are hitting so many people around this North America, this continent. So you know what? We're going to head over to hear more from a citizen scientist setting up their solar eclipse experiments out in Carbondale, Illinois. Let's take a look.
Eclipse Broadcasting Initiative, and it's a joint venture between NASA and Southern Illinois University here in Carbondale, Illinois.
And what is your role in the study? What are you doing as a citizen scientist?
Well, you said it. I'm a citizen scientist. I was recruited. I'm an alumni here from Southern Illinois University, and they contacted me prior to the annular eclipse, which we had last October, and asked me to record that from my home in Santa Fe, New Mexico. I kept the equipment, and then they asked if I might join them here in Carbondale. So I drove 2.5 days from Santa Fe and ended up here with all of this gear that you see in front of me to capture data of the solar eclipse that's happening today.
Your background is in the motion picture industry. You do not have a background as a scientist. How did you end up doing this?
That's correct. I worked in the motion picture business for about 25 years, and so I know cameras, but I don't know telescopes. So when they sent all of this to me, I had never operated a telescope. I had never operated a mount like this. Certainly I've used a computer, but all of the software was new to me as well. So there was a bit of a learning curve. However, I think that my experience, and boy, the crowd is really getting into it right now. I hope you can hear me. There's a countdown going on. But all of my experience in the movie business did help, and it prepared me to really figure out how to work this gear and get the data that NASA needed.
What is it about your experience capturing the annular eclipse in October that caught your imagination and made you want to continue?
Well, it really was something else. I didn't know what to expect. I had never been through a total eclipse, totality, or annular. Annular, of course, is when the moon only covers a portion of the sun, not quite the entirety of the disk. And it still was a very interesting, some people say it's a magical time. The sky gets dark, obviously, but there in Santa Fe, a breeze came up. It got remarkably cooler. I had to put on a sweater. It was October anyway, but still, when the sun was covered up, it's amazing how much energy we lose here on the Earth when it's darkened like that. And we saw the effect of that. So I'm really looking forward to experiencing that here when the entire disk is obscured by the moon. This should be really cool to see in another half an hour, 45 minutes from now.
What exactly are you doing here? You're on the football sidelines. You got a bunch of cameras and telescopes. What exactly are you measuring?
Well, NASA's going to have to tell me what they're using my data for. I really don't quite know what they're doing with the special files that I'm capturing using this material here, this small telescope. There's a mono camera here that records in black and white. I do have my other gear here, my DSLR over here. I've got one behind me that's shooting a wide angle. I've got the stadium in the background for that, and I'm capturing different phases of the eclipse as it happens to that camera. So when I get home, I'm going to take my images here and from the other camera, and I'm going to put them through Photoshop, and I'm going to make a nice collage of that. And in addition to that, I'm going to download the data for NASA, send it back here to Bob Baer at SIU, who's overseeing the project for the university, and I'm going to have to rely on them to tell me what they find in the data that I collect. I'm not that smart.
What do you expect to experience during totality? I mean, this is new for all of us.
Yeah, it really is. I know it's going to get cold. I hope I can see my equipment to be able to operate it, because it's going to get very, very dark very quickly. For 4 minutes, we're going to be experiencing that. I hope that we can hear the environment around us. I hope that we can hear the birds come out and start chirping and behaving differently. That happened when I was in Santa Fe with the annular eclipse a little bit. So I'm expecting more of that, only amped up because of the totality event today.
Great, thank you so much, Robert Dennis, and let's enjoy some more pictures from the eclipse.
Very good, thank you.
Hello, everyone. We're excited to be joined by Javen Gonzalez, Mesquite representative, to tell us a bit about how things are feeling here in Texas. Javen, welcome.
Hi, thanks for having me.
Yeah, and tell us a little bit about Mesquite, Texas.
So in Mesquite, we're known as the rodeo capital of Texas, so we sit just right outside of Dallas.
Okay, yeah. And how has being on the path of totality affected the community, local businesses? What were you feeling here?
So there's a lot of energy here in Mesquite, just from like a lot of local businesses, the volunteers downtown. They were really excited. We started planning for this a year ago, so we felt like the community is really well prepared for what's happening and all the visitors that we have.
And Mesquite and many other communities along the path of totality hosted full weekend-long eclipse festivities, and you guys were among those. How did you roll out the red carpet for, the local folks and the visitors?
Sure, so we actually kicked it off in the most Mesquite way we could. So it's the 66th annual rodeo parade. Happened here in Mesquite. So we have it every year, but this year it was solar eclipse themed. So that's kind of what kicked off the festivities. We met with all of our hotels. We offered them glasses. We had a lot of international visitors who reached out to us in advance, so we kind of prepared their vacation plans and where to go while they're here.
And where are some of the people coming in from?
We have people from Copenhagen, we have people from Spain, England, Mexico, several different states. So I just talked to some people from California and Arizona, so all over the place.
That's fantastic. So I've heard, like you said, that Mesquite is really well known for the rodeo. I'm wondering, how are you hoping to keep the momentum up, the energy and the excitement up after the eclipse?
Well, and one of the reasons why we called our Eclipse Weekend the Solar Rodeo was to kind of go back into that, because we want this to have a positive impact on our community, not just for this weekend, but for the future. I know a lot of people who have been here have been talking about, oh, we want to go to the rodeo now that we found out that you guys are the rodeo capital, and they've driven past the arena. So we're really hoping to capture those. We've been doing a lot of incentives to follow us on social media and come back.
And any things that you're doing with like the schools or the students and things like that?
Yeah, so we've been working with our local school district here since the very beginning. They're one of our big partners on this. So they have prepared all schools, so all staff, all students will have classes for today. They have lesson plans ready for today, and so all the kids are going out and observing. I'm sure they're out right now taking a look.
Were the schools closed today? It's Monday, or were they going on?
Schools are in session. Yeah, schools are in session here in Mesquite.
Any last thoughts? The weather, it keeps changing minute by minute. You're seeing it live there. Clouds are coming in, clouds are parting. We don't know what we're going to expect in 20 minutes. Any thoughts or any words of encouragement for everybody else who are also on the path of totality, possibly experiencing the same thing?
Good vibes. It's been blowing here off and on. The clouds have broken away and it gets really sunny and the clouds come back. So we're hoping that here in the next 20 minutes it's clear.
Fantastic. Thank you so much, Javen. And I hope things look up.
Thank you.
So we are going to have a look at all of the events that are still going on across Mexico, the U.S., and Canada. So stay tuned, take a look at our feed. If you need to find out about the latest updates and stories from around the country, you got to go to apnews.com. Check it out. We have a live blog telling folks, everything that's happening and all the weather updates, traffic updates. Earlier today, I saw there was already a standstill for folks heading up towards New England, so the northeast of the U.S. So if you want the latest updates, go to apnews.com, and we're going to continue taking a look around the country to see what's going on, how people are faring, and maybe we'll be lucky, just like Mazatlan, where the clouds will part just at the right moment. So we'll see. We've got high hopes here. looking at Eagle Pass, Texas right now, the border city on the border of Mexico and the U.S. And you know what? It's been cloudy, but people are experiencing totality, and they're excited, and they're just having such a phenomenal time. You can hear the excitement. In our feed, we're seeing a live view also of the eclipse feed from NASA, looking at the view from Russellville, Arkansas. There's just so much excitement and hope. So you know what, even if it's cloudy, you might just get to experience it anyway. The darkness and totality is just absolutely palpable. And even here where we are in Mesquite, Texas, everyone's just waiting. It's waiting. The clouds keep popping in and out. So, you know, there's just nothing quite like it.
Use the filter with us.
folks, here in Mesquite, Texas, it is incredible. The skies have cleared up a little bit. The clouds have parted just in time for, we have 3-4 minutes left to totality. Everyone around us have quieted down. All of the solar eclipse glasses are on faces. We're just here waiting. We are waiting for the moment. I think we'll actually get to experience this. It is so close. We have 2 minutes left. Now is the time. If you can, start looking down on the ground. If you're experiencing totality, notice what the shadow bandings look like. We've got clouds peeking through, but you never know. You never know if you'll get the chance to experience the weird shadow patterns. Take a look at trees near you. As totality is closing in, it's almost time. You guys, this is incredible. It's just slivers of the sun. And just in time, peeking behind the clouds. There is still a bit of cloud cover here, and it just so happens this one cloud is just choosing to obscure a little bit of the sun, but it keeps peeking through, which adds to so much excitement on the ground. I gotta say, this is kind of reminding me of the final moments of the Super Bowl here. Just the tension is palpable. People are just waiting on edge to see and experience totality if it can happen. But the fact that through the clouds and despite the weather forecasts, we are experiencing this, it is something else, you guys. We are moments away from totality here in Mesquite, Texas. Everyone is just looking straight up. If you happen to be looking on the screen at everybody else who's wearing reds, blues, greens, and colorful clothes, now is the time to notice the Purkinje effect. When colors are just changing, the temperature here on the ground is much cooler. All of a sudden, we are seeing the tiniest sliver of the sun peeking behind the moon. I am actually getting emotional, you guys. This is incredible. Five, 4, 3, 2, 1. It is totality here. Everybody just counted down together. Cameras are up, everybody's looking up, just experiencing this together. There are children, there are grandparents here all together. I am emotional. I can see a planet on the sky. I am crying and I can't help it, you guys. This is phenomenal. I wish Laura, our VJ behind us, could actually take a look, because you gotta come out from behind the camera, Laura, please. But we can see a planet just to the side, and even though it's peeking straight behind the clouds, we are seeing it so clearly. We are lucky that we had high clouds here today, just as this moment. It's absolutely darkness out here. It is incredible. There are folks taking photos with their cameras. They're not really going to get the ideal thing, but like now during totality, we're going to get 4 whole minutes of this, 4 minutes and 8 seconds. People can take selfies safely just at this moment of totality. And it is incredible. Look, the solar activity right now is near its peak, and just from the ground, we are seeing how powerful the corona is peeking through from behind the moon. It is just something else, you guys. And I gotta say, for all of the drama of the weather forecast today, the clouds have made it absolutely spectacular. It's just something else. I hope you all get a chance to experience it at home in the future, if you're lucky enough to afford it, for it to come to you directly. But it is just nothing I've ever experienced before. Yeah, let me grab somebody. Hold on. We're gonna try and get an interview with people out here because this is something else, you guys. So we're just waiting to see if we can chat with somebody briefly. Right now, I'm looking around. It is darkness. It is so cool. The temperature has definitely dropped. We're not hearing much when it comes to crickets or anything. There weren't a lot of bugs near us, probably because it's so busy. But oh my gosh. And we have someone here joining us who is part of Totality and, smartly enough, wore green against my red, so you can see and test out the Purkinje effect for yourself. Please tell me your name.
Melody.
Melody, and where were you coming from? Are you a local? Or?
No, Oklahoma City.
Oklahoma City. How is this experience for you?
This is very exciting. My husband went to the one that was in Kansas. Yeah. I didn't go, so I came with him this time, and it's once in a lifetime kind of thing. It's very different than what I had anticipated.
Yeah. Anything that stood out for you right now in this moment? I mean, the clouds were just in and out all day.
That made it more of a community thing. We were all cheering for the clouds to move, and every time there was a gap in the clouds, there was a cheer. But just when it got to totality, it was very, it was awe-inspiring. Just the ring around it and how it kind of had gaseous features around it. It was just very interesting.
Was it anything like you expected? How is it different from what other people have told you about it?
I had the correct expectation as far as when the eclipse was occurring, but the actual total eclipse, that was different for me. I hadn't anticipated the ring and the gaseous effect of the ring around it.
The corona, the sun's corona. Tell me your name one more time.
Melody.
Melody, thank you so much, and please keep enjoying the rest of our 2 minutes. It's already peeking out. Folks, it looks like the diamond effect might be coming through, or there's a little bit of light. It's a little confusing because of the cloud cover, but it's starting to get bright. You can see the difference right now in the light. It's just complete darkness earlier. It just felt like it was nighttime. And even with the clouds, you still feel it. And so, for everyone else still waiting for the totality to come to them, hold out hope. It could still be this good. Can I interview you? We've got one more person to interview here. Who's a worker? Are we good?
Right
All right. Tell me your name.
I'm Brittany Guareca.
Brittany, welcome, and tell us how are you feeling right now?
I'm feeling super. I mean, this is cool. Like, I have no words. Honestly, I've never seen this before. Like, I've never experienced an eclipse before. And the fact that I'm working and I am able to be out here and with my family and, you know, actually getting to see this in person, it's crazy. Yes, like I couldn't miss out on this.
How long did you know that this was happening? You're from Texas. You're from Mesquite.
I'm from Mesquite. Yes, well, I'm from Dallas. I actually went to school here in Mesquite. So I didn't know that, you know, Mesquite was going to be one of the best views of the eclipse from the whole. I was just like, oh my God, I can't believe it. And then I saw that people were traveling out here, and I'm like, dang, like. I've never expected this to happen in Mesquite, you know, because we're a small town. I mean, we're growing, right? But like, we're a small town outside of Dallas. And I mean, it's crazy. We had people come out and get coffee, and they're like, yeah, we're from the UK. Like, people were coming from all over, like, just to see the eclipse.
So how did you feel emotionally at that moment of totality?
I felt like this was so, I mean, I had my kids with me, so then I was like, hey guys, like, look up, and then they were like, wow, this actually exists. Like, we see it on the books, we see it, you know, and TV and everything, but we never see it live. So that was crazy. Like, I felt, yeah, that's God's creation. I love it. Yes.
What's your name?
José.
Spanish.
Spanish, yes.
¿Y qué tal? ¿Cómo fue?
No, bien, todo bien, gracias a Dios, estuvo muy bonito, una experiencia, pues, ¿verdad? Con toda la familia y, pues, trabajando. Vendiendo chilaquiles, ¿ok? Los mejores, ¿ok?
Okay. Thank you so much. Thank you so much, folks. Gracias. All right, folks, totality's here. We are heading over to keep chasing the umbra, keep chasing that moon shadow. And now we're going to toss it over to Hot Springs, Arkansas to see how things are faring. They've had good forecasts this morning, so crossing fingers for them.
then has a sticker on it that we're not going to be able to see totality because you're in a shadowed seat. If you are not already on your way down the field, get down here. I think everybody's down here, but I just want to make sure. And those folks taking it on the way, you have to stay out a little bit. I just want to take photos with everyone. That's totally fine too. We are just over 6 minutes between totality.
This isn't missing with anything. I've got a cord. Kathleen, will you go? Oh, yeah. That light is
begins in about 5 seconds.
We don't want it to go away.
We're going to take a minute and catch our breath here. Congratulations, you are now Eclipse Chasers. So, just to let everybody know, you've been such an awesome crowd. The Eclipse party is going to continue here in the stadium. We know that some of you are on your way out. If you have travel time available, you want to stick around because the traffic is going to be heavy. So just so you know, if you have travel time available, you can stick around with us. We're going to stick around for a little while longer and see if we can get any more eclipse feeds from some of the locations farther to the northeast. Hopefully in Edinburgh, Pennsylvania, if they're clear, so we will encourage you to stick around, let the traffic thing out, relax and enjoy. We are also going to highlight
Joining me now to talk about some eclipses and exoplanets and the universe is NASA JPL Ambassador. Welcome.
Thank you so much, Kyle. So excited to be here with you and see totality together.
We just experienced totality together and you were here with your parents. Tell us, how did that feel?
It's amazing to get to see the whole world change and to get to see the corona, which you never get to do otherwise.
Yeah, it was really strong today. And we even got to see a few planets nearby.
You could see Venus bright and clear. Amazing.
So tell us how your research has to do with exoplanets. How does today's phenomena have anything to do with that?
I mean, in the same way that you can watch the sun get dark, we can watch other stars get dark when objects pass in front of them. And it turns out when planets like Mercury or Venus make the sun a little dimmer, we can see this for distant stars and use it to find the planets that are around them. And so we found thousands of exoplanets, or planets outside the solar system, using this method.
So actually, you bring up a really good point in that total solar eclipses present an incredible moment for science experiments. As a matter of fact, didn't a 1919 eclipse make Albert Einstein famous?
In 1919, looking at the total solar eclipse, they were actually able to look at stars near the sun that you otherwise wouldn't see when there's sunlight and actually check Einstein's theory of general relativity. So it's amazing the science you can do both to study our atmosphere, the sun, and understanding all of space.
And final takeaway before we head out to see more of the eclipse, what do you want people to pay attention to as they're viewing it today?
How do you feel, right? All of the changes, it's not just what you see, the temperature, the people around you, the animals around you, and really sense everything, even if you have a magic bracelet with UV beads.
Thank you so much. And we will throw it back to our views across North America of the total solar eclipse. Thanks for joining us.
Thanks for having me.
much bigger than the USA.
All right, folks, we're back with maybe one of my favorite topics of the day, animals and eclipses. We're being joined now, or we will be shortly, from Fort Worth Zoo with Adam Hartstone Rose of North Carolina State University. So we're just waiting to get a chance to talk to them about what things look like at the Fort Worth Zoo. Hello, Adam. How's it going?
It's going great. This has been an amazing day at the zoo.
So it looks like it's a little bit sunnier now. It's kind of the same here in Mesquite, Texas. We're kind of on the opposite ends of Dallas. How was the weather earlier during totality for you?
The weather was pretty good. So there were scattered clouds, but during totality, I think that most of us had a magical view of the eclipse.
So tell us, people react to solar eclipses with oohs and ahs, and I mean, I cried. What do we know about how animals react during the total solar eclipse?
We don't honestly know very much about how animals react during a total eclipse, but we know a little bit more now than we did an hour ago. The animals here did great things. In previous eclipses, and especially our team did some research in 2017 at a different view. And most of the animals moved towards where they're put away for the evening, but some of the animals seemed very anxious during totality. We actually had kind of a different response here. While most of the animals did go towards their evening shift, the animals remained relatively calm. Some of them seemed a little bit confused, like did somebody forget to put us inside? But in general, like everybody was really well adjusted. Nobody was doing sort of bonkers behavior. The most amazing behavior was some of the animals that really didn't move very much at all during totality. They definitely looked around for their shifts and thinking like, I really need to go inside now.
So were there animals that were the same in your 2017 study and this one, or were they all kind of different? Can you tell us a little bit about, what was the same and what was different with your experiment this time?
We watched a lot of the same species. For instance, we watched a great group of gorillas in 2017, and we watched a fantastic group here at the Fort Worth Zoo. And they had a relatively similar experience. In 2017, they all moved towards their shift door, as they did here in Fort Worth. But also in 2017, one of the animals got a little bit worked up. And here, none of the animals got worked up. Some of them seemed to be a little extra vigilant, but not really stressed out. The biggest difference was in our experiences, prior experiences, everybody who watched giraffes during totality saw them galloping. And here at Fort Worth, the giraffe herd remained relatively calm. Maybe they sort of gathered together a little bit more. They gathered towards their evening shift area, but nobody seemed super stressed out.
How did you decide to start studying this research question about animals and their reactions to totality?
It was really an accidental thing. I was a professor at the University of South Carolina and affiliated with the Riverbank Zoo, both of which were on the path of totality in 2017. And we kept getting questions from the public about what do animals do during eclipses. And the truth is that we didn't know very much. We still don't know that much. But because of this lack of data, we decided to do a big study. And it turns out our study in 2017 was the largest study of animal behavior during an eclipse in almost 100 years. The previous study was done during an eclipse in 1932. And in basically all of those intervening years, there was sort of an observation of one species here and one species here, but nothing really comprehensive. So we did that comprehensive study in 2017, and here we came to try to confirm a lot of these findings and discover new stuff as well.
So what is next for you and your team? Any other eclipse chasing plans coming up?
Prior to 2017, I actually wasn't interested in eclipses at all. I was kind of almost jaded, and 2017 was mind-blowing. It was so cool. Coming here to Fort Worth, especially the Fort Worth Zoo, has been so welcoming and such an amazing organization to work with. I'm totally hooked now. I'm an eclipse chaser for sure. So we're planning to go to Spain in 2026. Maybe we'll go to Iceland. That same eclipse passes through Iceland. And then we're really excited about an eclipse in 2030 that's going through Africa and Australia. And then we'll be able to watch in the wild a lot of the animals that we've observed in captivity.
That's so great to hear. Adam, thank you so much for joining us. I'm so glad that the sun peeked through and gave you a little something. I mean, we were also on edge here waiting for that. So, you know, kudos and good luck with all of your research. Thanks for joining us.
Thank you. It was an extraordinary day at the zoo.
So we are going to take one more look across North America to see what's going on. People's reactions. Are they still waiting to see the eclipse? Has the weather changed? There's so many questions. But no matter what, we are all just nonstop excitement about today's total solar eclipse. So let's take a look around the country.